a lot of interesting game dev stuff, and there's I've kind of got like an actual outline of stuff that I want to talk about, which is a little bit abnormal today. Usually it's kind of free form. Today I've got kind of an outline over a document that I want to go over about just game development, what it's like working in the industry, and some of the really important lessons that this person mentioned in the article that we'll talk about, and that I think really, really ring true, like after working in the game industry and working as a programmer. And I think that if you're watching along and listening along, you'll probably see a lot of things that kind of at least make sense to you too. So if so, hopefully it's a lot of fun. Anyway, I'm just going to get started by mentioning before we get going with that Jason Story's new video is coming out after this. So if you're ready at the end of this looking for something else, which you definitely will be, check out the link below. Go add it to the wait list, or go add it to your watch later list so that you'll be ready for it as well. And what are you talking about in that video, Jason? And just briefly give a quick overview.
So I thought it makes sense to start my first video on starting a project. So I was reinstalling Windows, cleaning up my computer, and I have a lot of default things I set up. And I was like, you know what? Rather than just do it all again, let's turn on the camera and explain some of these decisions. So if you find yourself having a frustrating time starting new Unity projects and how you go through the process of getting it the way you want, this might help you. So there you go.
Nice. So, I mean, everybody here starts projects, so definitely go check it out. I watched it. It was a really good video, and I recommend that you guys go get ready for the premiere. Make sure that you're subscribed, and start watching for all of the other really cool stuff that comes up. And hey, Andrew, I don't know, just say hi real quick.
Hey,
Let
how's
everybody
everyone
know.
doing?
That, I mean, I'm doing great here personally. I know that
Good.
you're going out shopping soon, right?
Going out shopping, looking for a new place to live, maybe. So that's
Awesome.
exciting.
Very cool. All right, so I sent you guys both this article earlier, and I think you both had a quick chance to review it, right? I want to just briefly pop it up on the screen, and then anybody who wants to kind of follow along, the link is down below in the description. You can get an idea of what it is we're talking about here. But it was this article, an opinion piece that was posted on Reddit about things that have changed my mind on over working in the industry for 6 years. And I want to zoom this in a ton so that you can actually see the text on there. Let's see. So it really just a list of different things that this developer has changed their mind on after being a developer for so long, and going through the real world implications of, I guess, learning these things and seeing what it's like. And I just kind of wanted to read through a couple of them, talk about them, and see if they match up with you guys too. I assume they do, but if for people who haven't worked in the industry and are just kind of getting started, or kind of like in the beginning stages, some of these things might not make a lot of sense, and it might be problems that they're running into, or things that they haven't yet learned. So I hope this is really helpful, because I thought it was all good stuff. And the first one was just that typed languages are better when you're working on a team of people with various experience levels. I think that that's kind of an obvious one. If you're not familiar with typed languages, that's what you're using in C#, where you have actual classes, you have types, you have really strong auto completion on those, so that you know what things are valid and what things aren't valid long in advance before you compile or before you run. Have you guys ever worked with non-typed languages like JavaScript or anything like that in the past?
I'll be honest, when I first read that, I thought, like, what do you mean? Like visual scripting, aside from visual scripting?
Yeah, so
What do you
I
mean?
was thinking that, yeah, that was one of those things that I thought it's worth diving into, because I think this is my favorite of the ones on this list, or one of them, because it really highlights an interesting topic. So for those who don't know, the difference between typed languages and the non-typed languages is something called duck typing. Now, duck typing is a fantastic term, and it basically refers to an old phrase, which you've probably heard before, which is, if it walks like a duck, talks like a duck, it's a duck, right? And so the idea is, in typed versus untyped languages, so if you use duck typing in JavaScript, for example, you can declare something as a number. It's a number, and you can use it as a number. Then you can change your mind and go, no, it's a string now. It's a string. It does string-related things. And then everywhere in the entire code base, you're like, oh, it's a string now? Cool. It walks and talks like a string. I'll treat it like a string. And when you're new to programming, that feels like some magical superpower. You can write these really cool scripts where one variable changes shape constantly throughout the course of the application to do all sorts of weird and wacky, wonderful things. But if you're doing that, what you are doing is also confusing the hell out of yourself, because you are writing code with the presumption. Imagine how hard it is already trying to verify that a number is greater than 0 or less than a certain amount or within the right range or that strings aren't null. But now you have to check, is it even the right type? Was it provided? Is it still a number? It was a number a minute ago. Is it still a number now? And you get into these really weird scenarios. So I find a lot of younger developers really enjoy the freedom and power that gives you. But the older you get working with this stuff, the more you kind of appreciate the power of declaring and how valuable it is to have your code be very descriptive of its intent. And using these sorts of tricks don't always benefit as much as you think they do, because all they do is they obfuscate the intent of the code.
Yep, that's been pretty much my experience too. I remember thinking this is really, really cool when I found out about dynamics in C sharp, or just some other languages that I was using doing JavaScript stuff the first time. I was like, oh, this is really, really cool. I can just change this. This can be anything. But yeah, you run into those same problems of this is a cool power, but it's not a very useful power.
And don't get me wrong, I'm not saying that it's never valuable. I mean, a great use of it is the reason why it's so popular in JavaScript is you're often pulling data from the web, like big chunks of data. And if you had to make a custom class for every conceivable object that comes back, imagine you're getting a list of animals and then suddenly you add an extra field to the animal list. All of your code has to be rewritten to support one extra field. But the way you do it with dynamic objects is if you're reading a file or you're downloading information like give me the latest information about this podcast or this whatever, you don't need to know all of the individual pieces of data in it. You just get the object back and then you query it. You're like, oh, does it have a description field? Cool, I'll use a description. Does it have a title? I'll use the title. So that kind of dynamism can be really beneficial if you're doing remote or web-based things. And JavaScript being very asynchronous with how it's used, that's beneficial. But I only really use dynamics and things in C# for one of two cases. Either direct file system stuff sometimes if I don't know where the source is coming from, and web-based stuff. Predominantly, if I know what the type is, I would rather declare a custom contract.
The Bull has an interesting question in chat. Is var similar to a non-typed language? I have the same question.
Yeah. So this one is one that I think people often get this one confused and wrong. The reason why is it's very confusing in languages like JavaScript. Var is your wildcard. Var just represents it's a thing. It's something. I'll use a thing. And so when people see it in C# for the first time, they're like, oh, it's the same thing. It just means a thing of some type, but it doesn't. There's a huge difference in C# and JavaScript. In C#, the var is compile time, which means if you have var stuff equals 1, and then later on in the code, you write stuff equals the name JSON, it'll throw an error there before you even build or run the application. It won't let you go any further. So in C#, it isn't used for the same purpose. It is not about dynamically changing the type of the object you pass in. In C#, it is used for cognitive clarity in my case. But when you have an object, oftentimes when things get complicated, you have sentences that can be very long-winded, like object importer equals new object importer. That's a lot of words, right? And you can change that to var importer equals new object importer. You've cut down half of the amounts of things to process and think about when you're working with that code. There's other reasons too. I think the example I've used before is if you have sort of bicycle delivery person, deliverer equals new get deliverer, or sorry, equals get deliverer, you can see yourself falling into the trap of treating your delivery system by thinking about a cyclist, because right now it's implemented by the cyclist that does the deliveries, but you shouldn't. You should think about it as a deliverer, a thing that delivers things. And so writing var deliverer equals get deliverer, you don't even know if it's a bicycle deliverer. It could be a truck, it could be a spaceship later on when it gets more dramatic and there could be teleporters involved. You don't know. You care about the var, which says var thing I am equals get some content. And that way it forces you to reason about the contract and not the implementation details, which I think cognitively makes you better at coding. If you start to structure about the relationship between your intent and not the specific classes you're using.
Yeah, and you get the benefit there of you can refactor your factory, then your thing that's getting it to just give you back an interface, for example. Like if people are wondering like how that would change, your get bicycle could return to get moving thing that returns an interface that handles it. And as long as that abstraction was used, or the reference was just using the things that are in that interface, it would still work without having a change too. But it mostly just leads to much better readability in general. I mean, that's the key difference there, but not the magic dynamic stuff though, which was confusing to me the first time I saw it too, because I was like,
Yeah,
oh,
same.
var, it's just like JavaScript, which is actually more like dynamic in C#.
Yeah, there's a keyword in C# called
Yeah.
dynamic that serves roughly the same purpose.
Yeah.
So dynamic, my thing equals, and then new object, and you can dynamically change it. The only time again you'll ever really stumble into it is if you're using JSON.NET for your JSON parsing, which you should be, but for most cases that are more complicated than the basics, there's something called a J object, and a J object is something that you can parse into. And that can be used dynamically. You can basically query into that object of different types. If you've read in a JSON file and go, I don't know what this has. Is it a list? Is there stuff in it? Does it have names? I don't know. And you can dynamically build and query things. Or if you use the more complex link statements. So you've probably seen us do dot where something, order by, this, sort by, all of these different things. And oftentimes, if you have a large collection of data, say, for example, a big list of people and a big list of people's weapons, you might want to do something later where all you care about is the name of the person and the strength of the weapon. So what you can do is you can select all from people where some conditions, and then select a new object out of that that's just the names or just the parts you care about. So you can actually combine things and sort of dynamically build a new object that doesn't have a class associated with it. It's just bits of data from this class, bits of data from this class, and it'll return you a dynamic object that's like the couple of bits of data you want. That can be quite powerful. Again, I would favor a class in most cases. If you're doing this enough that you need to codify it into something, you're better with a class. But that's a case you might stumble across it. You might see new curly brackets with no defining type, and that might be a bit confusing if you've never seen it before. That's a dynamically declaring a brand new object in line.
Yeah, that's a great example of them. I was trying to find a good code example to pull up, but I didn't see one yet. Maybe just write one sometime. But yeah, you use those to when you want to access that data, usually temporarily. Like you said, you don't necessarily create a class because you're probably not going to keep that thing around. You're just going to form it into some data structure and then use that. And then a lot of time, once you decide that hey, this is going to be a more permanent thing, end up defining a class there and instantiating the class and assigning it. So yeah, I think overall though, in general, I think we agree though that typed languages are better when you're working. Let's just talk really briefly about why it's better when you're working with various experience levels, right? Like, so when you're working on a team with like people who are really advanced and people who are really junior, and I think for me the biggest difference here is kind of the key part that you mentioned at the beginning, which is you're gonna confuse the crap out of yourself by not knowing what the object is. And if you're a senior developer and you've got a group of senior developers that have worked together for a long time and they have kind of these patterns and they know what they're doing, it's not nearly as big of an issue because they're going to know, hey, what to expect and how these people are working. But as soon as you bring in new people and you bring in junior developers or developers who haven't done it that way, it's just going to confuse the crap out of them. And I think that's kind of the key point. You guys,
Another
okay?
small
Go
note
ahead.
on that just before as well is
Yeah.
another thing too is when it comes to types, early in your career, a lot of it seems, I don't want to say arbitrary, but like you're picking, I need a place to store a number, I need a place to store a name. But when you start to get further along, there are times you want to be hyper specific. Like we've done many checks in our code to check whether a number is greater than 0, so it stays in the right range. A lot of people don't realize this. There's actually a type called uint or unsigned integer, and it doesn't let the numbers go below 0. And that's not just an architectural quirk or design. It fundamentally stores less memory. It doesn't require all of that space to store the negative space numbers. And so there's decisions that you will make later on where you will choose the difference between floating point numbers or doubles, or why you'd actually want to use bytes instead of bools in certain cases, depending on the kinds of flags you're doing. That are decisions that are very important, right? They could be really critical for performance reasons. And if you're dynamically typing, if you get into the mindset of dynamically typing, you might pass over some of these very clear distinctions that people are making for that reason. So I find that even just from a early level philosophy, it's probably better to learn it typed so that you understand the decisions that are being made. So then you're better equipped to make the right choices with dynamic languages.
Yeah, I think that's very good advice. All right, let's jump on to the stand-ups thing. stand-ups are actually useful for keeping an eye on the newbies. Now, if you've never been in a stand-up meeting before, I think we should briefly just give an idea of what this is for anybody who hasn't done it. A lot of companies, a lot of tech companies and software companies in general will have a daily meeting, and it'll be usually around the beginning of the day. Most of the places that I worked at, the daily stand up was around 9 o'clock. So it'd be 9 a.m., sometimes 10 a.m. I think at Sony it was a little bit later on because people got in a lot later, but usually like 8 or 9 a.m., right around the start of the day when everybody is there and everybody's had a little bit of time to get settled in. And in those meetings, what we usually do is gather around, ideally, a big whiteboard that has the current project status, all of the things that are actively being worked on, the things that are going to be worked on soon, and the things that have just recently been done or kind of getting pushed over to our testing department or getting validated, right? And we go over step by step. Everybody stand up, like it's called a stand up because everybody's standing up in a group, almost in a circle around the board, or sometimes just in a circle if they don't have a board, talking about the tasks on the board or the tasks that they're working on, the status of those. Usually something really brief like working on this today, no issues, no blocking stuff, and continue on. Or I'm working on this today. I've run into this one blocking issue. Really brief, like here's my 30-second minute description of it. If anybody has advice, we can talk about it now or we'll talk about it after the meeting, depending on whether or not it's going to be a long running thing, right? And get an idea of who can help, who can contribute, and kind of push the thing forward. And then also loosely get an idea of where everybody else is at, and you could kind of see where the project's going and how things are going. I found that stand-ups in general can be useful for everybody if they're done right, or they can be a
That's a
giant
big part of it.
dreadful
Yeah.
waste of time if they're done wrong. And there's a big difference in right versus wrong. The right way is loosely how I just kind of mentioned it. We're going around step by step talking about what's going on, what the issues are, if there are any or that there are none, and then kind of figuring out a plan for how to resolve issues if we have to after the meeting, in little groups of people, the 2 or 3 people that need to get together. The bad ones end up being somebody stands up for 15 minutes telling a story about something and complaining about something, and then there's a little bit of a discussion about how to deal with that, and then somebody else does it, and then somebody else does that, and an hour in you've really accomplished nothing except for wasted a lot of time and everybody's tired from standing there. And I've seen that happen probably a good 50% of the time. It's not a thing that people do well in general. Well, what about you
Yeah.
guys? I mean, how's your stand-up experience been overall, and how do you guys feel about this?
Actually, I'm curious, Andrew, have you done many of those? Is that something that you?
In the roles I've been in, we're not developers, we're more marketing and stuff. We've done similar styles of meetings in the past. We've tried at least, and ultimately, the description you provide, Jason, makes a lot of sense, but it didn't make sense necessarily for us. We're a smaller team. We tend to work on the same things together, but in various we're working on them throughout the day together. But the concept of basically saying, hey, this is what we're doing and this is what we are, trying to figure out, and this is where I'm stuck, is a great concept. And that is something that I've tried to some degree with some success to do with myself, by myself, at times where especially on days when it's been like maybe 5 or 6 days between when I've sat down to work on a project, and I start by just thinking, and sometimes out loud and just talking to myself, where am I, what was I stuck on, what am I doing, and then getting going from there. So I try to give myself some stand-up desks in my personal time, but at the work, we don't do the stand-ups, but we do very similar things that is helpful.
I would say 90% of companies I've gone to. Oh, sorry, sudden alarm. I
Is it
think
for your
90%.
stand-up?
Yeah, exactly. I think 90% of the stand-ups I've been to have been a colossal waste of time. Although I agree with everything in that statement and everything you've said, but oftentimes they're done wrong because people don't understand the point of them. So, yes, you're 100% right. It's about giving people an update. But I think what really needs to be drilled into this is, so again, why is it a stand-up? Well, again, as somebody in the comments mentioned, it's meant to make you uncomfortable. You're meant to be quickly standing there so that you don't just chill out in a chair and have a nice chat for a few minutes. And I think people miss two parts of this. One is it's meant to be everybody. It's meant to be everybody from the business people right down to the developers in a lot of cases, or the people who care about it, from project manager down. And the reason why is the fidelity of it is meant to be, I'm working on X, I'm currently doing Y, I'll have this done by the end of the day. Oh, I need to talk to blank later because they have something I need. Done.
Or I'm
That's
blocked
it.
by this
Yeah, or
problem
I'm
and
blocked by
need
this
somebody
issue.
here to volunteer to help.
Exactly. And then you go around the room, and the reason you do that is you highlight where people need to spend their time so that anybody who's planning their schedule for the day can say, oh, they need help, I need to catch up with them, and they can figure out what they're doing. And then everyone breaks. And two important things happen there. One, you end on a note of everybody engaged in the current problem. So the last sentence is somebody saying, I also need X, right? Break, let's go. And the second part of that is you now have a good sense of what everyone's working on, so you know who you can work with or who you're helping. But two things tend to happen in most stand-up meetings. One, discussion. People tend to start saying, I'm stuck on X. Someone says, have you tried this? Oh, well, we could do this. And not only is that a waste of time, that's not what that meeting's for. Oftentimes you have cross-disciplinary people. So you're basically having a bunch of people from art departments and from QA and from dev. And that might sound like a good idea. And even the people who aren't interested, fine, you're wasting their time, but they're not going to listen. The real problem is people who are going to look at it from the wrong fidelity. So I've had these meetings before where someone says, oh, I'm stuck on this issue. And then someone honestly trying to help says, oh, have you thought about doing this? And it's like, we're not even talking about the same thing. We're working on the same systems, but like we're down here and you're talking about it from here. They're different problems. And any contributions they make, they're not realizing the question or the issue that's happening. And so you don't want to muddy the waters by having the discussion in a space where people from looking at it from different angles and goals will engage with it. If you have a meeting to have that offline. You basically structure what meetings you're going to have. And the second one, like I said, is people often end it with something like one company would end it with sort of a theme of the day. You'd tell jokes or you'd do some sort of you'd share memes or something, and that's fine. Like the idea is meant to invigorate people at the start of the day, but what actually happens is everyone ends the morning meeting off work topics. They started the day ready to work. You talk about work, and then before you've even left the meeting, everyone's already chilling out. It's like you've completely broken that like initial morning motivation of getting everyone started. And it's meant to be a huddle. It's meant to be everyone rounds up and goes, working on these things. Everyone ready? Any issues? Cool. Go. We'll catch up again at lunchtime, see where we are. Break. Done. It's meant to be this quick, energetic thing. And yeah, it's often not that.
Yeah, those things are good at the beginning of a rare meeting, right? Like an icebreaker type thing that tend to be a big distraction. I've seen that a lot though, where people get distracted right after the stand-ups. But good stand-ups, I mean, they do happen. I have seen and been to quite a few good stand-ups where like I was actually getting a lot from the stand-up, learning a lot about what was going on and seeing a lot of kind of not so much cross-disciplinary, but cross team and across the engineering department in general, communication and interaction that helped out a lot. But I've also, like you said, been to at least half of them have been bad. More than half probably have been bad.
I will say to kind of even counter my own words, the value, the point where it is valuable that you might, in case you're worried that it won't be, is there is a problem that programmers have where you end up falling into this pit of seeing a box around you. I work on this code. When my code works, my day is complete. Everything is fine. I don't care how this fits in. And so you can find yourself working on really big projects where there's people who are spending their whole day trying to get clients or deal with bugs or QA stuff, and you forget that you're a cog in a big wheel of stuff moving on. And so having that morning meeting and having people say, oh cool, they're getting funding and they're working on the art and they're talking about the website and they're doing sponsor stuff, you may not care about the details, but it's a very firm reminder that this is a bigger deal than you, and you can feel more culpable for the decisions you're making. And one last note too, because we didn't really touch on it, the reason specifically I assume the writer of this article mentioned for keeping an eye on newbies is because when you're new to a team or company, you're very worried about taking up other people's time. You often find yourself when you starting a company that you're like, oh, all these people know more than me. They're all working on big business important things, and here's me just sort of pottering around trying to learn things, and I don't want to take away from their time. And well, that's a perfectly fine thought to have. It just means you're sitting there learning nothing and doing nothing, and you're wasting everyone's time by doing that. And so, and it's often not meant maliciously, it's just an accident of what happens. And so people are shy, they don't want to speak up because they don't want to waste other people's time. So in a stand-up meeting, you can have somebody say, I'm trying to learn how to X. I don't know where the code base is, or I haven't got logins for this yet, or whatever. And normally they would be too shy to speak up about that. But now it's like, cool, whoever's free, help them out, go do it, move on. And everyone gets to go along. And they can talk about their issues in a space that's comfortable enough that everybody can hear it, everyone can help them out, and they don't feel like they're targeting a person or wasting their time. So it's particularly useful for that.
Yeah, that's very true. And for just highlighting when they're having problems and they're stuck on it. Because a lot of the time when you're a newbie at a place, it can be uncomfortable to just admit that you're not sure what to do next and you're having a problem and you're stuck on something. So you can see really quickly that the junior developer's still working on the problem that they were working on yesterday or last night, and you know the solution's simple. You can give them some guidance and kind of lead them along the way. And if you see they're working on the same thing for a week, you know that you really need to intervene and kind of dive in. So it does come in really, really handy for keeping an eye on the newbies. And I think it's probably something that if you're hiring new developers, you should definitely be doing. You should be having regular stand-up meetings. Just try to your best to make them quick and not terrible. Right? Like, even if they're bad, they'll still probably have some value. But try to make them good. I'd watch Chris. Chris does a lot of talk about stand-ups and meetings. Go check out the Mob Mentality podcast. Chris Lucian's show is a good friend, and he talks a lot about this kind of stuff, and he's got a lot of good insight into it. So highly recommend it. Let's talk about the retrospectives real quick, because this is something I'm a little bit less opinionated on. It says sprint retrospectives have their place so long as they're for actual course correction, i.e., holy shit, that went poorly, and not some god awful agile / scrum master waste of time. So I've seen these kind of I haven't seen a lot of sprint retrospectives. I have seen a lot of project retrospectives, or like update
Postmortems. That's what
retrospectives,
yeah.
postmortem type ones, or like where it wasn't specifically for a sprint, but it was for maybe like a set of sprints. At Sony, we'd do them, and they'd be more like quarterly or like a update, like based on a big release or something, a patch. And then other places I've had where we did them somewhat regularly. And I would say that those generally weren't nearly as valuable, the regular sprint retrospectives that I had, because we really just kind of like said a lot of the same things over and over and didn't make any changes to them. What about you guys, though?
I mean, again, in our role, we don't do sprints, so we don't do sprint retrospectives, but we do plenty of retrospectives on campaigns, promotions. We now do a monthly retrospective, which it's technically supposed to be about what we've learned in the past month, but it tends to be everyone's supposed to attend. People who barely work with us are supposed to attend. It bubbles up to management and above and all this, but in the end, it feels like most people just sit there and listen and ignore it. And I don't know the impact because it gets so dense. And I think the problem with the way we do it is, everyone's busy with their own stuff. Everyone's working on their own stuff. We're all working on the same big promotions, but the most interesting retrospective content is the nitty-gritty details about small things that did or didn't work really well and why. But that also gets very boring and dry for people who are just like, hey, I do social media and that's cool, but all I need to do is talk about how many posts we did and how many likes we got and why. And so you get into this point where everyone just says stuff and nobody really remembers. And I don't know if the impact ends up happening the way it's supposed to happen.
It ends up falling into this airing grievances and catharsis of people just basically complaining about what went wrong, which is definitely the wrong way to approach it. I definitely see what this comment is talking about. Specifically, in larger companies, the sort of retrospective is used as a way of saying by the kind of the project managers or the financiers or the people who aren't kind of the nitty-gritty portion to effectively lay blame. Like, the truth is, it's used as we had a burn down rate, we said we'd do X, we didn't achieve those goals, Y. And it's a very easy way for people to say, oh, this didn't work because X, Y, and Z. Obviously, that's not what it's for. It's actually for us to say, hey, did we overestimate certain things? Did we underestimate other things? Do we need more people in this area? Is this this person may be our best programmer, but they're being taxed too much. Maybe we need to find a way to put them on more priority stuff. Maybe one person actually, in a retrospective, somebody might say, I actually found myself having a lot of free time. And it's like, oh, that's fine. That's not a fault of one person. It's just an oversight in how, like, how come in the same sprint, one person is really free and one person's really busy. Very clearly, we can do something about that. I find that less useful too for the same reasons, because let's be honest, people talk. You have lunches. You rant already. People are usually well aware. The only people who don't know are when you have to give one of these to managers to say, hey, we've learned our lesson. We need to get more people in this area. But again, I would have those meetings off separately with managers. I wouldn't like rope the whole team in and then basically berate people for getting the job wrong. Where I would say it's very, very useful is, as what Jason was saying earlier too, with the postmortems, which is the best example of this is things like game jams. If you do a game jam, half the learning is the excitement of getting it done, powering through, doing all of that stuff, and like finally finishing it. The second half of the learning is, okay, why did it actually take me way longer than I thought? Why was I stuck for 3 days? And if you stop and actually analyze that, so again, you called it like a game postmortem or a game dev postmortem, you can stop and go, I don't appreciate how much time it takes to add audio to the project. I assumed it would be X time. It was actually a lot longer. Next time, I want to budget for more time for that to happen. Or I spent too much time in this rabbit hole where I thought this idea would work, but then rather than taking a step back and then trying something new, I spent too long looping that. So it's great for you personally to question yourself and how you approach the problem. And so postmortems in particular are very, very useful, but I think they only really get their benefit from a small, close-knit team of devs or just one person as a self-retrospective more than the scaled project one.
Yeah, I found that most of the time they tend to be things set up by managers, so managers can kind of figure out why things happened when all the rest of the engineering team already knows, right? All the rest of the team knows exactly why things went the way that they went.
But
But
to
yeah,
be fair, though, I will say one thing in the respect of them. One thing, again, developers are really bad at is they don't respect the job of the business. And you have to be honest with this. A business has a certain amount of money, and every time your butt's in a chair, whether it's typing or not, it's costing them money. And if you come back to them and say, well, we had accidents, stuff went wrong, it took 3 weeks longer, that's fine. Things are allowed to take longer than you think. But to be honest, you did just cost them thousands. Your it took longer is magically thousands disappearing from their account that they're genuinely curious what happened. And so you can eye roll and look at it as them being pedantic and being annoying and laying blame. But the second half of that is to say, well, are they right? Did we mess around? Did we actively just like cost money for no reason that we didn't have to? And if you can be honest with yourself, you can find a way to soften that relationship by being more straightforward with people and working out what that is and figuring out, look, it's a problem, let's solve it. So there's lots of things around. That's a much bigger topic, but I think in general, just keep in mind they're not doing it to annoy you. They're doing it because there was a deadline, there was money, people were promised things didn't get delivered, and it's perfectly fine if they want to question why the hell that happened, right?
yeah,
And
go
really,
ahead.
oh, it's just an action needs to be taken. That's the you have to learn something and then build on that. So if you put out all this information, whether it's why something took longer or why something didn't perform as well or why some new mechanic you put in did X, Y, Z, whatever it might be, what's the next step? What do you do? And if you don't have a what do you do and act on that, then the meeting was pointless.
You're doomed to repeat yourself. Yeah, exactly. If you haven't figured out the problem and put some actions towards solving it, you're doomed to have the same problem next time.
Without a doubt. And for anybody who's struggling with the whole like it taking longer not being a big deal thing and costing more money, I mean, you've got to think about it a lot like if you just went to go buy something and suddenly they double your bill because they're like, oh, yeah, it costs twice as much as we thought it was going to. Sorry. Like you got a quote on it. We told you what it was going to cost. And, there's your good friend that told you and then they charge you double. That's essentially in the back of their minds what's happening, right? Like this thing that was supposed to be a great deal is now getting more and more expensive. All right, I want to talk about software architecture for a second since that's the next one. It says software architecture probably matters more than anything else. A shitty implementation of a good abstraction causes no net harm to the code base. A bad abstraction or missing layer causes everything to rot. Um overall, I would say that I generally agree with this statement. I don't know. I mean, it says probably matters more than anything else. I'd say it's right up there at least at the top of the things that matter. And the core part of it here is that just missing your abstractions, not having any abstractions, and not having any thought about the architecture at all tends to lead to big, giant, monolithic messes that fall apart and kind of crumble underneath the weight of themselves. At least that's always been my experience. And then people want to destroy them and recreate them. And so, I thought it was kind of just an interesting way to put it, though, that a shitty implementation of a good abstraction doesn't cause a lot of harm because like you can fix that implementation of the abstraction, but having the seams and the abstractions right is, I guess, the more important part. What do you guys think about that? Has that? I assume Jason's probably got a lot of thoughts on this. Actually, before you answer this, can everybody hit the thumbs up button? That little thumb over there is sad. The one down there because it's covered by my name, so you guys can't see it, and nobody's hit the button. So I figured I would let everybody remember. Anyway, yeah, Jason, what do you think about this? Do you think software architecture matters more than anything else, or right at the top, or where
I actually do think it matters more than anything else. I take issue with the idea that effectively it's a bad implementation of a good abstraction causes no harm. Because I think there's an example later on, even in the same document, where they say, YAGMI is the most important principle to take, which kind of goes counter to that, right? Like, if they're saying that if a good architecture done badly is better than none, then YAGMI wouldn't.
Well, I
be
thought
true,
they meant
right?
a bad implementation of an abstraction that was necessary, like a good abstraction that's needed, but a bad implementation of it, like it's
I
just
guess,
done
yeah.
differently.
I guess
Like,
my worry is I put an asterisk with that, given that the first few comments are about
Mhm.
newbies and people who are starting. I would say yes. I would cautiously say yes to that statement, but I think the problem is it's better to have simpler code when dealing with people who are having trouble learning these concepts. But I would say, yeah, let's get off the very niche answer to that one thing. And I would say, to me, I think software architecture is the most important thing because everything else derives from that in terms of requirements. So, for example, people talk a lot about there being a counterbalance between architecture and performance. And the more architecture you put in, the more you're going to suffer on performance because by definition, you're putting in layers, and those layers are things that have to be traversed and they cost performance. That is true, but the thing that I think people miss is if you have, for example, an inventory and you have an abstraction layer to that inventory, and you're currently using a poor performance version of it, you're doing some big list in memory that's chunking through stuff, or you're opening a text file every time you want to save a new item, you can fix that problem because the abstraction layer means your code won't break if you fundamentally gut and replace it with a more performance solution. So even in that example where you're talking about performance being key, putting the right architecture in place to allow you to address the issues with performance is more important. So I think 100% architecture is the most valuable thing because it allows you to solve for the biggest issue in software, which is change. The one thing you can guarantee, no matter what code you write, stuff will change. The code will change, your requirements will change, and everybody's been there where you've gone through your code base and had to do a mass copy and paste or a mass delete, or you gut some old system, or you're afraid to break it because it's wound into 15 things and you can't change it. All of this is a symptom of bad architecture, and the problem with it is that you can't change it. And because of that, you're stuck with the bad implementation. If you had good architecture, bad decisions can be fixed behind the boundaries of good architecture. So I agree.
and Andrew, I assume you're 100% on board with that too.
That sounds amazing. Everything he said is exactly what I would have said. Exactly. Now, I do think, with my limited experience, foundational stuff seems very important to me, and it's something that I'm personally trying to focus on for the purpose of knowing that I'm going to change things later. And that means I don't know how I'm going to change it later, but I'm going to. So I really want a flexible foundation that would allow me to make changes without having to go back to the very beginning and rewrite everything from scratch or an entire system from scratch.
This is actually, it's funny because this is a conversation I had earlier today about something called the law of Demeter. And I think this really highlights one of the biggest issues I see in code where people are having trouble with architecture. So if you don't know what the law of Demeter is, it goes by another name, which is the principle of least information or least knowledge. And what it means is, and you've seen this yourself, even if you don't realize it, it's whenever you have dot something dot something. And so if you have, the example we were using was player dot inventory dot add something. It's a fairly innocuous statement. There's nothing crazy about that. But think about what you're actually saying there. And for contrast, first we'll jump to something else. So lists. If I asked you, how does a list work? You don't really know, right? What's inside of a list? How does it function? It doesn't really matter. I've said this before, but the truth is it's actually an array that automatically resizes itself when it needs to. But here's the thing. If overnight Microsoft said, it's a dictionary now, I'm just changing the way internally all lists work. Granted, it would have performance concerns, but your code wouldn't change. No part of your code would have to change to support drastically changing the implementation of that system. And that's why, because when you use a list, you are using a list. You're not using the parts of a list. Now, in contrast, if I had a player.inventory, what I'm saying is I am giving an item to a player using an inventory. So I've actually baked in the implementation I am using with which to give the player the inventory in the statement. If I said player.give item, I'm giving an item to a player. And what does that mean? I don't know. Maybe they use an inventory. Maybe they use a magical bag. It doesn't really matter. If I say player.inventory dot, I'm giving it to a player's inventory. And the reason this is important is if you did that in 100 places in your code and you said, you know what, inventory is not working, we're switching to a networked magical bag, or we're switching to a teleported war chest or something. Every place in your entire code you wrote player.inventory dot is now different. It has to change. It doesn't support the old way of doing things. So in general, avoid talking to the internal parts of a system. There are other solutions around this. I got into this bigger thing earlier, but I guess to put it another way, take something as simple as a shop. If you have a shop where a player can buy items, ask yourself, is it really a player buying items, or is it someone who can purchase things and an item that are buying items? Now, I don't want to get into the layers of architecture and philosophy of that design, but my point is, if you pass a player to a shop, so the shop says player.inventory.add item you purchased, that shop can only ever work with players. If you pass a client or a purchaser to a shop who happens to be using a player's inventory and a wallet from somewhere, you could theoretically have a player using their friend's wallet, or you could have an AI who's using your player's wallet and buying things for them automatically. And all of this free technology and features are available because you're not tying the shop to a player. But if you pass the player in, you're intrinsically saying player.inventory dot, it has to always use that track of that player. So that's just one example of one of the most common sort of architectural problems where people, it's called leaky implementation. It's where you show me how you're doing it, not only that you're doing it, but how you're doing it. Every time I can see the inside of another class, I am locking those two things together and I can't change them.
Sorry, I hit the wrong button there. I was gonna say you see that a lot through making things public. When you have public things on top of public stuff, and then you're accessing, when you got multiple dots there, it's kind of a good sign that that's what's happening there. That you're exposing way too much. Um, yeah, that's a very good set of insight there. Also, I mentioned if you're interested in game architecture, I got a course there over my head and down below in the description. You can learn a little bit more about it. All right, you want to go on to Java? He's going to lie here and tell you it's not terrible of a language. It's actually not that terrible of a language. It's just not one that I particularly love or have any use for. It's very similar to C Sharp. C Sharp's kind of like, I feel like it's Java 4.0. It's like the newest, better version of it that handles all the stuff it does and does things a little bit, at least in my opinion, better and an easier way to understand, an easier way to get a lot more done and handle it. But it's not that terrible language. I'll give them that. Right? It's a good foundation and
Yeah,
a good
like
learning point.
I still think Java is one of the best languages to learn first. And now I may be biased because it was my first love as a language. I actually learned in order. I think it was kind of HTML, some tiny bit of JavaScript, then VB, then onto Java, and then I went down ActionScript and C# and other stuff. But Java was the first language I went, oh, this is what programming is. VB infuriated me. I hated it. It was this archaic, confusing nonsense. But Java was the first language where I'm like, oh, I can make conditional statements. I can pop up little dialogue boxes to people. I can engage with the concepts, and I can do events and all this other stuff. It's very verbose. You end up having to write a lot of plumbing code. And there's the one big thing, which I think it's kind of weird to describe for people who haven't done it, is how exceptions work. So you're probably not too familiar with exceptions in Unity if you haven't used non-Unity stuff outside of the null pointer exception that you get from time to time, or null reference exception. So the main thing with Java is if a method can throw an exception, you have to declare what exceptions it can throw. So basically, you mark a method by saying it can break in these 3 ways, which is really like good for declarative whatever, but it means that it bubbles. So if I have one piece 12 layers deep where I add a new thing to my code and it could possibly be 0 at some point, everyone who ever pays attention to that has to know that. And as we just talked about architecture, changes at low levels which break high level stuff is insane. You should avoid that at all times. So it has some quirks, it has some issues, especially with the way it handles with Java on Android. But as a language, it is fundamentally where C#'s design came from. And so I firmly agree. C# is my favorite language, and it's effectively Java with the quirks ironed out. But I don't hate Java. I just think it's not. There's just something older and more archaic about it relative to the newer stuff now.
There was a question or a comment that popped up that I wanted to talk about real quick too, and it said about the last part on software architecture that this it reminds me of the story that I'd mentioned before about my buddy Jared, who had to fix a 10,000 line method to move inventory items. So this was on EverQuest 1, and he was doing a method to I forget what it was, doing something to extend out the inventory. I think it was going to be for the in-game housing inventory to support that or something. He needed to make it so that they could add more inventory slots. And the method for adding an item to inventory was 10,000 lines long. It was like that method alone was that long. I mean, I've had some files that were that long, but that method was that long. And just like you can imagine the indentation of it, it's just like a bubbly mountain range if you turn it sideways. And it was a nightmare. He spent 6 months ripping it apart to get it to work the way that it worked before, right? Just to get the base functionality into a way where it was manageable, where you could make a change to the inventory system without breaking it. Because I think at that point it had gotten, I mean, I didn't work on that system myself, so just anecdotally from hearing from other people, but it had gotten to the point where making minor changes to it was kind of a terrifying thing because it was probably going to break things. And when you break things in an MMO, you can destroy the entire economy. You can like cause things to need to go rolling back, or all kinds of big issues, especially when it comes to inventory. You break stuff with inventory, you lose all people's items and have giant CS nightmares, all kinds of stuff. So it was just that was one of the big reminders for me that keeping code clean on a project that you're going to keep around is extremely important. Because I mean, that was 6 months of one of the best engineers on the team, and like 25% of the team or something at the time working on just fixing that one method. So it was,
and this is one of those one of those things where it's so hard to see why when you're new or working on small projects, because the truth is a lot of people haven't worked on a project for 3 years or 4 years on the same code base. But once you do, every single time you cut a corner or did a shortcut or said, it's good enough, all of that compounds. And you end up seeing this. It's kind of amazing when you see big companies where they're working on software and the productivity has dropped to a crawl, where unironically you'll have a meeting with a group of people and they'll say, oh, can you change this number to this number? And it's like, sure, we'll have that done by next week, because we have to find the 15 places in the code that it's all been declared differently with a different calculation that make sure they all match. And we have to run all our tests again and verify it. And this isn't, again, people weren't being lazy doing it. It was just like small shortcuts here and there, but they add up to the point that people have left the company, new people have joined, and you're paying the costs of this. And because it's not been designed correctly, nobody wants to fix it. Because if you fix it or try to fix it and it breaks, it's your fault now. You own it. It is your problem, and you are stuck with it until you get it back working again. And so this is the biggest reason why architecture is important, because I really can't stress this enough. It's not about the fanciness of clean code. It's not about how pretty it looks. It's about the freedom to change things and be safe in the knowledge it'll work. If something as straightforward as, I've used the example before, if you wire a device directly into your wall and the device breaks or the wire breaks, you're screwed. It's done. Like you would have to possibly rewire part of the house to fix that problem. And so what you're doing is you're forcing a huge potential breaking change across everything. If it's a plug socket and a plug socket and one thing breaks, you unplug the thing, you plug something new in if the device breaks. And so that's all code architecture is. It's, can I take a thing that's currently doing X, unplug it safely without anything breaking, plug in a different thing that currently does nothing, and then slowly build in new features. And that way, if a feature needs to change, I take out an old one, put in a new one. That's all it is. Changes happen over the course of a large lifetime of a project. Requirement changes come in. You get new requests for features. You get calculations changing, and the better, or UI is changing. So wants to redesign something. The more freedom you give yourself to change old stuff without breaking retroactively all the other stuff and causing regressions, that's all it is. So every time you ask yourself, should I put in this pattern or do this style? Ask yourself what it's for. And the answer is, does this allow me to change this decision later without having to go and like hope I didn't break some unrelated concept that's touching it over here vaguely? That's all it's really for.
I totally agree. Yeah, that's good stuff, man. Sorry, I was thinking about like some other scenarios there, but I think I'm just gonna leave it there. I think that was, you kind of covered it really well, and I want to hit this next piece. Unless you had anything else to add on the architecture part, Andrew. No. All right. So
Nope.
yeah, clever code. So this is one that hits people a lot when they're, I would say maybe at like the 1 to 2 year mark, where you start figuring out that you can write all kinds of clever, tricky
One line.
things
How
that,
much code can you fit into one line?
yes, exactly. And it says clever code isn't usually good code. Clarity trumps all other concerns. 3000% agree. So you can write lines like a single line of code that does some amazing thing, does the entire method in one line, but nobody can read it, and you have to go in and explain it. And you can write up these like tricky little statements that like, oh hey, can you figure out what this does, and give it to somebody as a puzzle. But you don't want puzzles in your code. Yeah, you don't want people to have to try to figure out what a line does in your code or what a method does in your code. If it's clever, it just means that it's doing something that isn't obvious and isn't apparent. And that's exactly the opposite of what you want in any code that you're actually keeping around. If you want it for like a puzzle, a challenge thing, cool. Clever stuff is neat there. Outside of that, in a real code base, though, where you're going to have to look at it and read it again, and other people are going to have to, it's a terrible, terrible idea. Oh.
Yeah, pretty much.
Makes a lot of sense to me, especially considering I'm going to come back to my own code a few months later and not know what's going on. So being clear.
Yeah, I've written stuff like that. I just don't. I read it like 6 months later, like, what the hell does this do? Like, oh, well, I was trying to be sneaky and tricky, like trying to be clever.
Yeah, I have to fight myself from time to time because one of the benefits, I guess, of using C# for as long as I have is I've learned all of the weird and wacky syntax, right? I know how to hide things using the automating functions and how to do all of the cool overriding of things where you can do behaviors that it's not meant to do, but it hides it and makes it look really magical. And so I try very carefully to only use that in my own code bases to make it read cleaner, but where I don't expect people to understand how I made it read cleaner. But if I'm giving it to somebody who's working on it, I'll actively not use the thing that would make the code look nicer because it's too confusing. Like it just wouldn't make sense to a lot of people. The examples I've used before are things like overriding the implicit and explicit operators and using the object initializer syntaxes and various other tricks that are just not worth the confusion they could cause people.
Yeah, I think overloading operators is the one that irritates me the most because it's not something that new developers or a lot of developers even consider, and then they get stuck trying to figure out why the hell something weird is happening. So I try to avoid doing that unless there's an actual like extremely valid reason for it. Things like that. But anyway.
I do want to just before we go further, because one comment I wanted to make on one of the questions asked was about, we're talking about clean code and architecture and then prototyping, and the question is, does all of that architecture stuff really apply there? Now, I would say the very cautious line here is, imagine you had you're prototyping weapons. You're making a new game and you want to test out weapons. If you have a relationship between a player and a tool, so player equips a tool and then uses a tool, you can write the crappiest coded gun you've ever written in your life, providing it's a tool that you give to the player. Because what you've done is all of that hacky, messy stuff you've done is in a nice box called this gun. And so for prototyping, that's the point of prototyping. It lets you kind of rapidly swap out behaviors and test things. The architecture there, it isn't about writing it perfectly and unit testing every portion of your code. It's about saying, can I just draw a line here? I am going to change how health is calculated while I prototype. I'm going to change how guns fire. I'm going to change what guns do when a bullet lands. I'm going to change that from being explosive or corrosive or fire or whatever else, and maybe it explodes into other bullets. Maybe it drops enemies. I want to give myself the freedom architecturally to be able to swap that out without having to like write an if statement and change the code and possibly break the old way I did like when I try to add a new one to test it. So the architecture should be freeing enough to allow you to swap in behaviors, but inside those behaviors, go crazy. You can write messy code for all I care, because that behavior can then be unplugged and a better one can be rewritten in place. And the code that is robust and staying there will grow and get better.
Yeah, I think the important part is to just improve the code after you're done with the prototyping. Once you have a good understanding of how it's going to work, how the system is going to work, if it's something you're actually going to keep, you're actually going to have weapons in your game that act like that. Then start to solidify the architecture around it in a way that makes sense. Once you know that the thing is being used and how it's being used and how it's going to interact with things, and start to build up the architecture around that so that you can swap that thing, you can change it, and you can do the other things that you need to do with it. I think that one of the things people dive into sometimes a little too early is kind of predetermining what that's going to look like and predetermining how their interactions with their different systems are going to work when they haven't even figured out what those systems do. They still don't really know.
Don't make guesses.
Yeah.
Make the first gun directly as you need it, and then the minute you're going to swap out a new one, ask yourself, well, crap, what needs to change from what's here to put in the new one? Well, put a box around the stuff that needs to change, take it out, put the new one in. Only do it for each new thing. And after you've done this 3 to 5 times, you'll stop and go, hang on a second. A lot of these are looking the same. Now I can start building a relationship and a contract between them. But don't guess. If you ever find yourself writing the I weapon interface and it's got no methods yet, because I'll figure it out later, you've already confused yourself, right? Because you've already gotten to the point you're building abstractions for things you don't know exist yet. So start with actual practical code, and the abstractions happen. They will appear in your code as you go. Don't try to start with them.
Yeah, that's generally what I would stick with. Now, Andrew, I know we only got you for a few more minutes, so was there anything else you want to talk about before we lose you to the housing market?
We'll see. No, I think that was a really good answer, Jason, and that and the talk about just using the methods in various ways to say purchase item versus player dot inventory dot whatever. These are things that as I've been coding more, I find myself starting to think about as I'm coding, which I really enjoy. Because even when prototyping, I realize it's probably best practice to say, okay, it takes me all of 5 minutes, not even 5 minutes. It takes me all of like 30 seconds to turn this into a different method. I should just do that. And then time and again, I keep finding myself saying, oh, wait, now that that's its own method, boom, 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 boom. All these other places I could have just done that. And so these are things that being quick or being clever aren't always the best idea, I think. And it's I've been noticing that for myself, and it's just been something that I've been very fulfilled, like realizing as I'm coding. Yeah.
Good to hear.
So yeah, that's it. So that's good stuff. I'm gonna cut out. I'll see you all next week. Thanks everybody, and I'll have to listen to the rest when I'm walking. See ya.
All right, man. Well, good luck on the hunt.
Thanks.
See you soon. Thanks again. There was one follow-up question here about what about abstraction through scriptable objects. And I just wanted to briefly talk to you about that, and I want to fix this layout too because this is just weird. That looks strange. Here, let's put the text there so it can. That looks weird too. Okay. Anyway, what do you think about scriptable objects? Do you use scriptable objects a lot personally?
I do. I use scriptable objects anytime I have to move data between scenes. But I would say this kind of answers it's funny that the statement proves itself in its statement. What
Well, I
about
think about it.
abstraction via scriptable objects,
Can
right?
I cut in and clarify real quick? When I
Yeah,
think
go ahead.
about abstraction through scriptable objects, what it makes me think of is those scriptable object game architecture systems where the entire game is built on scriptable objects being linked to other scriptable objects that are variables and events and things. So I just wanted to cut in with that because that's what I'm picturing with this question. Yeah, I
Right. Oh
want to
yeah.
see if
So
that's not what
that's
you're.
that's not what I was thinking at all. I was thinking more abstraction by definition is to hide the details, and then saying let's abstract this with a scriptable object kind of defeats the point to me, right? It's like saying
Right.
let's hide the details of how we're doing. Here's all the details, and it kind of defeats the point. But in the way you're describing it, sure. Like I don't know. It's just another tool, right? Like in scriptable objects, they're just a thing you can use. In the example you're describing, they're being used to make events easier to work with across scenes, but the kind of technology you're using or the pattern there is still the observer at its heart, right? The scriptable object is just a means with which you're doing it. So
Yeah. That's fair. Yeah, I personally like when it comes to the scriptable object pattern for building games, I am not a big fan of it myself. And I've seen people that really succeed with it and do a great job with it, but it's just it's too outside of code for me. Like,
I'm well, it's well documented that I've said if you're like what the point of code. This kind of comes back to one of the other things too, so it might be worth clarifying. In my opinion, the talking about clever code or writing code that's too smart for its own good. What's the point of code at all? Like any line of code you write, what's the point? It's to distill your intent. I want a system that can X. And the whole point of you writing a line of code is to tell the system, do X. This is the thing I want to happen. You are describing your desired behavior. And so if you try to phrase it like a puzzle, then that's like asking for a meal and actively making it a confusing question for them where they might get it wrong and then being angry if it gets it wrong. That's silly. You should write the intent as clearly as you know how to do. And if your code is written if the architecture is written outside of the code. So again, if you're using event architecture, there's no line of code that says your intent. Your intent is when character dies, send a score to the scoreboard. But if all of that logic lives in this event hits this event, which triggers this, which fires these events, where's that line of code? Where's your intent? I can't look at the code and say, oh, they meant if enough damage is hit, player dies, player sends score. I can't see that anymore because you've hidden your intent in the stitching of events. So as a general rule, I want to be able to read per method, it is trying to X. This is what it's doing.
so you don't want a giant event chain where you have to keep following them up and then figure out what thing got deregistered and why nothing works right and why
Then you're
something's
bubbling the
firing.
event bus and it goes in like then you hit that one where like an event causes a callback and it starts firing the same events in loops
Yeah.
and oh yeah.
Yeah. At least when it happens in the same frame, you'll get a nice little Stack Overflow. The worst is when it's like, oh yeah, it kicks off next frame. You're like, what the hell is going on with this game? It's all broken. No, I've or not even game. I've seen it a lot more with non-game applications where they get into the event hell. So it's
Or even just remote apps, right? Where you've got like an external Amazon sort of AWS Lambda, and it's just like, oh, it's magic. We just send requests to the Lambda and it figures stuff out. It's like cool, but why did you let the guy who receives Lambdas send Lambdas to the Lambdas, and now you're stuck? Now you're in this infinite hell of events getting stuck and backlogged.
infinite lambda loop that costs you millions of dollars or waits until the credit card hits the limit. So here, let's go on to the next question. That bad code can be written in any paradigm, or not question. The next statement, I guess. So I would say that that's obviously true. Like,
Yeah, I think it's pretty self-explanatory on that one. Yeah.
yeah, like the way that you write the code is not gonna or the way that you build your code is not going to necessarily lead you to good code. You can write TDD or any other system you want, and you can still write terrible code. And I've seen it in all different ways. Let's just go straight ahead to the next one because I don't think that there was much there to say about it. And it said that the so-called best practices are contextual and not broadly applicable. Blindly following them makes you an idiot.
Well, I guess the problem with a statement like that is blindly following anything is bad. Like it's like saying is too much of X too much? It's like, well, again, it's a self-fulfilling prophecy. If you have too much of it, it's too much. I think when it comes to best practices, there's two categories for this, and I think this is very important to note. I do. Let me just grab the book because why not? These are the two linchpin books of the argument: clean architecture and clean code. Actually, I have issues with clean architecture. I'm not going to talk about that now, but I would say clean code. This book, everything in it is broadly applicable, because this book isn't about how to do code a certain way. It's not about what you should specifically do, what systems you should use, what architecture you should use. It's about craftsmanship. That's why it's in big letters there on the front, because the idea is being a good citizen. And what I mean by that is, it's how do you write code that you will enjoy using and other people will enjoy working with. How to just name things in a way that's declarative. It makes you think about what your job as a programmer is. Why do I write code? What is my goal? And everything in it is the philosophy of how to approach problems like this. That is all broadly applicable. But those kinds of philosophy of how to be a programmer it's a very small part of the equation. 90% of programming books are how to do tests this way, or how to use this system, or why MVVM is better than MVC, or all these other things. And those fall into dogma, and they tend to be silly arguments where people fight over, I happen to be eating soup, so spoons are better. So objectively, spoons are better for everything. It's like, well, no, your problem with your solution works well. Other people with different tools will have different problems to solve. And so a lot of the best practices, you have to be very careful when you apply them. And the perfect example for this is the amount of ex-enterprise devs who start in Unity, and the first thing they do is start throwing in all of the design patterns they're used to from enterprise, going, I've got all these powerful tools I'm used to, have been using, it's going to make my code so much easier. And they just, it's hell. It's really hard to work in Unity using the classic enterprise tools that you're used to.
Yeah, that was one of the things I did, definitely, and I've seen a lot of people do. And you start to
Same.
see things that worked well in one scenario for a specific problem, and then you start to try to pull them in because, hey, it's a best practice, and then realize like it's not, it is for that problem, not for the new problem that you're solving. And you got to really look at the problem that you're trying to solve, the system and the solutions that you're using, and make sure that the practices that you're using actually apply to your project, your workflow, and your tech stack, right? I mean, all of it has to kind of line up. um let's go on to the next one. I'm going to start popping these up here instead of a little text, so that people can see
That's a
our
good
big
idea.
faces and not little tiny text. So this might work a little bit better. And it says, designing scalable systems when you don't need them makes you a bad engineer. Oh
True.
yes.
150%. Yes.
Yes, without a fucking doubt. I mean, it's like, it's one of the things that people struggle with the most, where they think that they need to make everything scale so that it can handle being World of Warcraft, or handle being Twitter, or whatever other thing. Like, this thing scales up to 1 million players, or this thing can run on an iPhone 1. Like, giant waste of time on both of those things. And it's something that people focus on often, either too early or too late. So when you actually need a scalable system, it's very rare that like you've got it already kind of planned out and ready to go. But most people don't need a big scalable system, right? Most people need a scalable system because they built the first system and it was a sudden success and hit, and suddenly they're like, "Oh crap, we need to be able to scale this up." And you see that with like any of the big systems that have come out in the past. They were all like that. They all start off not really being ready for scaling, and then as the problems come, they kind of adjust and deal with it. It doesn't mean that you shouldn't be prepared. Like, if you know you have a scalable system, you know you need some scale, like you're going to have 1,000 users from all over the world hitting this thing at the same time, make sure that you can handle more than 1,000 users, right? Handle 2,000, whatever it is. Know what the scale that you're going to be at is, but don't just guess some wild, out of the blue scale, like number of players that we're going to have to deal with, or things that we're going to have to do, and try to build the game for that. Or that, hey, we're going to have 10,000 different NPCs, or what if we need 10,000 different NPCs in our game? Well, let's make the system so that it can handle 10,000 NPCs. And you find out like the actual game design's got 20, right? Like, stop wasting your time. You're literally just overcomplicating. And really wasting your time, your money, and other people's time and money with that when you build out these systems that you just don't need to solve problems that you don't have. And it's just basically solving problems that you don't have. It makes you a bad engineer, right?
I think there's even two parts of this. One of them is the code scaling portion, and one of them is the DevOps scaling portion. And so I'd say from the code scaling portion, um, it's kind of like there's the stages of grief. Well, there's also the stages of becoming a developer. And one of the stages is you inevitably hit the point where you fully get all the simple stuff, and you're like, now I want to learn architecture, and you start learning it, and you start realizing there's all of these patterns and practices and buzzwords and all this stuff. And the first thing you do is write, before I write my next system, I'm going to get out the notepad and I'm going to start writing hundreds of classes and interfaces and stuff. And I'm going to build this super modular super system that you hate using, that actually doesn't work, because anything you try to change breaks everything, which defeats the point of the big, complicated, supposedly scalable architecture in the first place. So that's just a phase everyone goes through. You just have to get past that and eventually settle back down to trying to write simple code. But I think the second one is probably the more important one. It's the one you're talking about, which is where people who are even very experienced will design systems to solve problems that you don't have. And I think the real issue with this is what we talked about earlier with architecture. People think good architecture and scalability are the same thing. They're not, because what good architecture does is allow you to change things later. So for example, whenever I build an API, if anyone ever asks me to build a RESTful API, a standard, get resources, get put post, classic REST stuff, I will always, on my first draft, make an in-memory list, and the entire repository of items just stores in a memory list. If you turn the API off and on again, you lose all your data. But you know what? It works. And I can keep writing my code with this bad implementation, because when some people say, well, that won't scale, obviously you need an API that if power turns off, you don't want it to break. It's like, yeah, but right now it's being run to me on my machine. There's 2 people using it maybe at best. And so this is fine. And then later on, once we start adding it to the rest of the team and other people want to try it on their devices, I'll put in database migrations or something, and I'll now have more. And they're like, cool, this works, but what if we want to scale it to, thousands of people? It's like, well, when that time comes, I'll put it on AWS, and I will then make a back-end version of the repository that goes to some web version of stuff. And so the point of good architecture isn't designing something scalable. It is designing something that can be changed to be scaled when it needs to. And so that's why I think change is the key word. You want to design your code so you draw safe boundaries that lets you make decisions later. Defer those decisions.
Yeah, I think that's exactly right too. I don't know. I love listening to you talk about these things, man.
I catch myself sometimes, like I don't mind having a chat as often, but there's sometimes like a baked rant that I know I have, and I can even tell my inflection changes, and I just go off on a rant, and it's kind of like a fugue state. I wake up and go, oh, have I ranted about something again? Oh god.
I think it's important to remember that, and I think just not, again, don't solve the problems until they're actually problems. Maybe be prepared to solve them, but don't go out of your way working and building these big giant systems that you don't need to solve problems you don't have yet. Solve the problems that you do have, and then deal with those ones as they come up. You're always going to have something that's a little bit more important to solve, and deal with that stuff first. All right, the next thing on this page, and I'm just going to pull it up to show it real quick, was static analysis is useful. So if you're following along, I linked the Reddit post down there below. You can check it out too, and the blog post. But I think that this is generally, of course, true. I mean, this kind of goes back into the typed languages, and I think just using good tools. Static analysis of your code is generally useful. What do you think about this? Do you use any static analysis tools?
Not really. No.
Okay. Well, we can
Not
just kind of move on from. I don't have a lot to say about it either, other than it.
I guess the closest you could say is I do sometimes use code coverage metrics. Very rarely. I will do it in my tests. I will. I think code coverage is one of those things that gets into muddy territory of falling into dogmatism too. But I would say having your test be verified, having your code be verified that it works as intended is pretty good. If you start getting into the static analysis where you start doing things like automating line count checks and other stuff, it starts to get silly. Like I don't really see judging metrics by how big modules are and stuff is super valuable.
I think it can come in a little bit more useful when you're working on a bigger team and you've got a lot of people's stuff coming in, because then you can start to see some of the differences and see things that people aren't necessarily talking about that they're doing bad, right? And you can kind of catch some of those things as well. But it's yeah, it's not something I've got a lot to talk about. It's not something I use a lot in Unity, to be honest. I used it a lot more previously in web development stuff.
Well, there's a lot of stuff that falls in that category, right? I've dropped a lot of my previous weapons in my tool chest when you use Unity. You have to use different tools for different problems, as we said earlier.
Without a doubt. So dry is about avoiding a specific problem, not an end goal unto itself. And for anybody who doesn't know what dry is and why it's capitalized, it's just the mantra of do not repeat yourself, which is just essentially stop copying and pasting and rewriting the same code over and over and over in your project. Consider making methods or making reusable chunks of code. But it says that it's not about avoiding it's about avoiding a specific problem and not an end goal in itself. And I think that the core of this is saying, like, just because you duplicated something, like, your goal shouldn't be like, hey, we need to turn this into a one shot. We should turn it into a one shot shared method if it makes sense. Not that it's like the goal is everything uses one method and then maybe that method's got a bunch of overloads and other crap and it's even worse. Right? You want to dry is about avoiding code that you have to change and update in multiple places is really kind of the goal, right? You want to have so that if you make a change to a system, you don't have to change that in 5 different places because you copy and pasted that 5 times. You want to change it in one place. But you also don't want to run into the problem, which people do, where they take a lot of different things that are doing things differently and reuse the same method, because then they can't change that method without breaking all of those things. So it's
this was
go ahead.
This is honestly one of my, like, of all the things that we talk about, it's one of the like 3 or 4 biggest things that took me the hardest time to learn as a developer. I will fully admit this was one of my biggest failing for years, because there's something really enticing conceptually about building your core utility library that has all of your cool math functions you've found and all of the helper things. And what you really don't realize when you first start is if you build something called my math utilities and you put a bunch of methods in there, every time you use that in another system, think of it like attaching a piece of thread to another piece of your code. And so what you're doing is you're causing connections. You're making things more complicated just because what did you really need? I needed my own custom map function. It's a single line of code. It's a little algorithm. I could be tempted to make an entire class called math utilities and put it in it and share it. And now if somebody asks me, oh, can you give me that script you wrote that does this thing? It's like, sure. And also take my library with you too, because you need that to call like 2 methods, and it's ridiculous. So the reason this exists is because an example, I literally had this. I worked in a company where there was a number being calculated, and that number was dependent on whether a big enterprise system, whether a user was allowed to do something. And that number was very important. It was calculated and said, if that number is a certain thing, they can. If it isn't, they can't. And this is like big money here. We're not talking small systems. There's a lot of money involved in this stuff. And I was tasked with changing that number, to which I found out, like I said earlier, it was in 2 places using 2 different equations. Very similar equations. They're not like too far off, but between the differences between number rounding and one of them stored in SQL in a stored procedure and one of them stored in C# in the code base, that they're done differently slightly, it's like, hang on a second, you're telling me at different times throughout this application, this number is being calculated slightly differently, and you're using that as a calculation to compare against stuff, and it could be off by as much as like 0.2 or 0.3. That's a big deal at times when you're talking about money and rounding and other issues and stuff. And so the idea of don't repeat yourself is, if you're doing something, and this falls into the category of business rules, if there is a rule your system must abide by, a player can never do X unless they have Y. You can't open this door unless you have the key. That's a rule that you should be theoretically put in one place. And you can check the rule and check if the rule is true. And if the rule changes, actually, you need 2 keys. Actually, you only need to have had the key for, if you've seen the key, you can open the door. Doesn't matter what it is. You can change the rule, and that means you're not repeating that question in multiple places. Because if you change it in one place and not in another, suddenly everything's wacky. You're like, why is it half working? And sometimes it does, sometimes it doesn't. So don't repeat yourself isn't a targeted architecture. It's the idea that if something is a rule, you're saying the system should do this, that rule should be free to change like everything else in one place and propagate its changes. But you don't want to just be sharing a line of code that's valuable just because you use it a lot. What I'll often do is I'll put it in a utility class, but when I need it, if I'm only using it once, I will actually copy that method into the new class and just use that one function. If I suddenly start using 5 or 6 features from my API or my little code base, I'll be like, oh, now I'll bring in the whole thing because there's already intrinsically 7 or 8 ties to that system. Well, then now the system's actually first class and I can then remove those little bits. But if I'm only using like a sliver of it, there's no reason for me to bring in this entire thing just so I don't repeat a line of code. So that was a personal hard fought lesson. I can honestly say I spent years getting that one wrong.
Yeah, when I first learned the acronym, I went through somewhat a similar problem where I tried to abstract everything, put everything into a base class or into a shared library, and you quickly will see what the problems are once you try to make a change to it. It's an easy one to kind of hit yourself with, and then you just have to realize what's going on there. The next one was just to remind everybody to hit the like button and share the stream if you haven't done that already. Makes a big difference. Definitely appreciate it.
I
And
also agree with that one. Yeah, that's another one I agree with. Is a
then that one you agree with. And then the statement after that was on here was, in general, RDBMS is better than or greater than NoSQL. So what they're talking about here is relational databases for storing your data. And this doesn't necessarily apply so much to game developers. Most game developers are abstracting this stuff away with some sort of a service, or there's somebody else on their team that's dealing with the back end saving side of stuff. But in general, I tend to agree. I'm not a huge fan of NoSQL solutions for saving most data types. I think there's some data that works really well with it, but I've never been a huge NoSQL fan myself. Not that I have anything against it. I just have found that most of the time the problems that I have are solved better in a relational database, or there's just less that I need to do to get it working in a relational database than in the NoSQL scenario. But I'm curious, have you done much with NoSQL stuff or
I
relational
have.
databases stuff?
I've done a good bit of DynamoDB, and so this one's funny. This one I've gone back and forth on. I've been dogmatically against SQL and relational databases. I've been dogmatically for NoSQL at different stages, and then back and forth. And so I now think that my opinion on the subject is I was misunderstanding the point and the difference between them. So from a project perspective, it's about saving stuff. Forget about everything else for starters. I have a bundle of stuff and I want to put it somewhere and save it. Use a save system. I don't care if it's a file, if it's a list, if it's a relational database, if it's a NoSQL. If you do that bit, draw a line and say, take stuff, give me stuff, find me the thing with this name, done. Job done. Now the question is, why would you pick one over the other? Well, there are concerns and there are reasons. There's not a direct, I think this falls a little bit in the dogmatism to say one is technically better than the other. I prefer, and I think more use cases use relational databases, but I'll explain why. NoSQL, actually, we'll start off with what SQL is first before you say NoSQL, because that's what it is. NoSQL brands itself as being actively against SQL, so it's worth explaining. So
Even
SQL,
though it's SQL-like.
it's very SQL-like, yeah. So SQL stands for Structured Query Language, and it effectively means the way the database works is relationally, and that's why it has relational database in the name. And it means that you have sets of data. So if you think about storing your data in a giant Excel sheet, it's just a big list of stuff. There's no like relationship or connections. It's just a big pile of data in one big pile. But when you use a relational database, it's kind of like the way you're doing object-oriented stuff. You would have an item over here and a player over here, and then players have items, and then an inventory would be player and item, and you relate the information to each other. To get really clinically into that, you start falling into categories of what's called database normalization and something called normal forms, and you can get into NF1, 2, 3, Boyce Cod. You can go down this whole thing. But what it means is how atomic have you made your systems? How many relationships can you make between abstract things? And it's worth noting, these aren't the only 2 database types either. There's graph databases, which are different altogether, a whole different architecture. But the reason they exist is because they are insanely powerful for querying. If you have a relational database, you can start asking really particular questions. Get me all of these, where this, on this date, join it against this set of data for each one of these where that's this and this is that, do this, but only if this happens. And you can get these really, really distilled, powerful queries.
Yep, like I get a query on all the clerics that finished this quest between over this weekend and got this reward item, right? And then get that exact list back of just those people and easily, right? Like it's a super simple thing to do.
It's relatively performant. You're not getting back extra information you don't need. It's got a lot of benefits to do it that way. And the way you do that is using generally something called indexes. It's where you actively index per table saying, I will ask this question regularly. So be ready for this question and optimize the searches for it. In contrast, a NoSQL database is more flat in architecture. And what it means is it's key value pairs and lookups. And you end up doing this sort of like breaking and sharding your data so that you divide it into chunks. And what that means is data is actually blindingly fast to get large sets back, but querying it starts to become a problem. And this is the difference between using something like if you want a simpler version of this, it's like using lists versus using something like a dictionary. If you want to find a particular thing by name in a list, you have to search each item and find the one you want. In a dictionary, you pass in the key reference of what you want. And likewise, with relational databases and with fact databases or sort of more NoSQL ones, you don't use the complicated SQL syntax. You ask simpler questions. It's just indexes, just lists of things, and you get back effectively filters or scans or whatever the language or the structure calls it. But it's effectively flatter views. You have a lot less power in those kinds of queries, but it's stored in contiguous memory and it's faster and it has a lot of, it isn't built for querying, it's built for recall. So what often happens in much, much bigger systems is you actually don't store your database in one place. You actually have multiple architectures. And what you do is the query comes in and there's an in-memory Redis cache of like the last 1,000 things that were asked for are right here. We check it's currently Halloween and the Halloween quests are being done every 2 weeks or every minute somebody's doing this quest. All of the Halloween items are right here. We don't need to go and pull it from the back drawer of a database because it's constantly being asked for. Then next up from that is the slightly less used stuff, but still requested regularly. And that would be stored in the NoSQL database. So you'd actually have like this week's or even the active users right now, what's going on, who's active, what are they doing, which quests are running, this kind of stuff. And then way at the back in the huge, big monolithic store is where you would have the history, all of the data, all of the items, all of the stuff. And in a smarter system, you would look at the pros and cons of each, and you would bounce the data back and forth per what you need to do, depending on how you're caching the data. So in short, NoSQL isn't intrinsically better or worse, but there was I would say statements like it's worse usually come from people because there was a wave. I'd say, I can't remember when it was, like 2010 maybe-ish, where there was like NewSQL was the new hotness. Everyone wants to use it. Databases are dead, rip databases and basic stuff. And it was this whole new thing everyone was so happy with. And it's like, the only reason people are doing that is because one, they like new shiny toys. And two, SQL's hard to learn. It's not easy. And what a lot of people don't realize is big companies hire DBAs, separately programmers. There's a guy whose job it is to manage that database because it's hard. Like you need to know a lot about sharding information and how to deal with stored procedures and how to set up your indexes correctly. And so it was really fancy for companies to say, hang on a second, we can just bring in this NoSQL stuff. We don't need to hire a separate DBA. Our programmers can just learn this simple NoSQL stuff and we can do simpler things. And obviously doesn't go well.
Let's be fair, though. That was more the engineers not wanting to deal with the database administrators than the company, right? It was the guys going, I know I could just do this in NoSQL and not have to deal with the DBA and all these rules and locked down restrictions of stuff. That was a lot of what I saw pushing NoSQL was like people who saw it as a way to have a database without having to have a DBA that was limiting them and locking them down. I mean, usually they're limiting them and locking down for a reason, though.
Right? But that's why I felt the same way, right? I came from I did SQL in college. I hated it. I started doing programming. I was like, I just want to store data. I don't want to learn all this horrible database nonsense. I just want to save data. And so I, eschewed all of the horrible database stuff and went with the fancy NoSQL stuff. And it wasn't until I worked in bigger systems and realized it's like I said before, it's like I'm just choosing, I'm never going to use a fork because spoons exist. It's such a silly, reductive mentality. There's no point in limiting yourself. It's about knowing the tools, using the right ones, and knowing when to use them.
Yeah, and I think in general, for people who are curious about it, NoSQL is probably used as much as relational databases for game dev stuff because storing off things like player data actually fits relatively well in a NoSQL database. You have this nice little encapsulated bit of data on a player. if it's not too crazy, too huge, and you don't need to query it or do a lot with it, you can just shove that in just like a flat file or a serialized JSON file. Is essentially what it is. You're serializing some JSON, shoving it in there, pulling it right back out, and it's extremely easy to work with less setup stuff than the relational database. But the relational ones, in enterprise, you're going to see way more of it, and even in games. I mean, every game company that I've ever worked at had relational databases, had SQL servers or Oracle databases, or a combination of both, and database administrators. Like there've been DBAs everywhere dealing with that stuff. And sometimes at Sony, I mean, we had like a whole team of DBAs and multiple teams of DBAs working on it because it's lots of data stuff. So it's an interesting one. Let's jump into functional programming. I got this one here.
Okay, if we're doing that, I need a quick bathroom break if I'm going to have to talk about functional programming.
Well, then let's hit like and share instead. I'll give you just a second. So yeah, if you're still watching and you haven't hit the like button and the share thing, please do it. Like I said before, it does make a big difference. And I really got to get that little divoom screen that Jason's got there right in the middle of his background there, the little black box there. Been wanting to get one of those forever. It's like this cool little fancy screen to show some neat stuff on. I keep forgetting about it, and then I see, God, he's got a lot of books up there too. Wonder what all those books are. Anyway, the next question or the next thing on that form that came up was about functional programming being another tool and not a panacea, which I guess maybe I'll wait for Jason to come back, but I kind of want to just briefly talk about it. Actually, let me just ask in chat. How many people in chat are using functional programming day to day, like in your actual real world projects? If you are, can you just loosely mention something? I'm just kind of going to get a rough idea of like what the number of people are that are using it. Because I think functional programming, a lot of the time people think of it as like it's the alternative or the solution to all of their problems. And I think that's loosely what he's referring to in this post. And it's really just another way to think about writing code. I mean, it's kind of the first way to think about writing code. It's the way that code was written before we had object-oriented programming. And it's certainly not going to just magically solve all of the problems. It really just, in my opinion, prevents you from making some common mistakes over and over. What's up, Jason? Welcome back. Sorry, I was admiring your books and your divoom thing, and just I was loosely talking about the question here, or the mention of functional programming. How it's not so much that it's I guess it's just that I think people misunderstand it as like this magical thing that solves all of the object oriented problems, gets rid of all of your performance problems, and makes your code suddenly magically good. And I think that a large part of that is coming from people who see the functional code. They don't really understand what it's doing, and they think, oh, this looks fancy and cool. It's probably really good, and I've heard good things about it, without really diving into what functional programming really means and what the benefits are versus the payoff there. So I don't know. You wanted to take a break real quick because I know you got a lot of thoughts.
Yeah,
So what do you got?
I had to psych myself up for this one. God. So before we start, whenever I bring up the spoon fork style analogies, this is the thing that popped into my head. It is this topic, because the whole question of there was a certain point, I forgot exactly when this was, but there was a huge big push in the direction of functional programming, and there was like people going ding dong, oh, object oriented programming is dead. This is it. It's the new thing. We're all going to stop doing object oriented programming. And it was so silly. Like the whole thing was so naive and just hilarious that whenever I think of people like dropping all their tools because they found a new shinier one, this is the one that comes to mind. Functional programming is great. It's really, really good. And there's a reason why C# has been slowly stealing functional ideas and putting them into C#, and why F# exists at all. And I think it's the idea that people think that you can just ditch paradigms like that really highlights a lot of the problem. I would say functional programming solves a couple of really big issues, which is state, just as a general thing. Is if you have trouble with a lot of programming systems, it's often because something went wrong. Something's meant to be true that's meant to be false. Something is -5 when it's meant to be 4. It doesn't matter what it is. There's some number, some system. The thing's meant to be open, but it's closed. And functional promises you that's not going to happen, because functional is basically, if you give me this set of inputs, every time I'll give you this back. And there's something very, very psychologically freeing about stacking these promises together, where everything is guaranteed to be the same, providing they're the same. And it makes code very, very easy to test and work with, but it is harder to reason about. And so you're trading that cognitive clarity and stuff we talked about before for a level of bulletproofness in certain areas that can be very, very powerful. Now, the thing is, I've said so many times, different tools for different jobs. Functional programming is more mathematically oriented. It is extremely good for calculating algorithms and for doing things that are mathematical derivations, and people use it for a lot of AI type stuff as well. Like there's a whole separate argument too, which is functional objects, to avoid state, have to keep duplicating themselves. So that the way they do it is you clone things effectively, and so there's a memory cost to having like a list repeated just because you don't want to avoid mutating the state of a list. Less of an issue with modern computers, but it is still an issue. But either way, the point is there are pros and cons. Again, it's not a straight easy one is better than the other. You don't get to say because I've solved all of my state problems, my code's magically perfect. It's like, well, no, you have other problems now. Your problems just happen to be memory and garbage issues, and you have issues with it being harder to understand, and you have to atomicize so much stuff that stacking the functions together can get confusing, and there are other issues effectively. Personally, I prefer object-oriented code because I just find that my goal has always been intentionality, writing code that declares what I want. And I find I personally am very good at the mathematical reasoning of the clarity of functions, so I avoid it a lot of the time. But if there's great features that it has that are being migrated into C#, I'll use them. So because they're powerful. So I think again, learn the tools, pick what you like, but don't ever say the other thing is dead because this one's better. That's just, you're just asking for trouble.
Yeah, and don't just try to switch because people said that that one was the way to go. I'm kind of the same. I primarily use object-oriented code and occasionally do something functional, but it's usually to solve a very specific problem. It's not so much for like my general flow and architecture, because I personally struggle with reasoning and wrapping my head around an entire project that's completely functional. Like it's still something that doesn't translate really well for me, I guess. And I don't know if that's true for everybody, but it's
I have the same problem with reactive extensions. I really dislike when people start using RX for like everything. A good example of this is when there's the reactive extensions in Unity, which are really powerful. Again, really great uses for data transformations. But when you're doing stuff like turning the inputs into ticks for update loops, and if if player presses X, do Y, but you're doing it through streams, you're just obfuscating and confusing your code for no reason because you're using fancier tools. I just don't
Yeah, that's
understand
gonna
that.
get us right into, I think, the next one. Well, the second to next one, because I'm gonna hit the button to remind everybody to hit like and share the stream one more time. Just go drop it on Facebook or Instagram or whatever you drop videos on, and then let's talk about the one that I think is really gonna. This is probably the most important part of the whole paper, right? And it was Yagni, solid, dry, in that order, and it's just three really important acronyms in the exact order that I would put them in. And I think the
Yep.
first one is probably the most important, which is the YAGNI, which is short for you aren't going to need it, or you ain't going to need it.
You
Like,
ain't gonna need it. Yep.
yeah, it just means essentially not to build shit that you don't need, not to overcomplicate and over-engineer your project. A lot of the time,
Mhm.
almost all of the time, people do this. People get an idea that they have this thing that they want to solve, this system that they need to build, and they over-engineer the crap out of it. They come up with like this big idea for how it needs to work and this big architecture around it, or they start adding in all of these extension points that they're never going to use, right? If your game is only guns and you make your system so that it can handle any kind of weapon, you're wasting your damn time. You're not going to need it. You're literally wasting your time. Anything that you put into the game or into the code that doesn't necessarily need to be there, that isn't going to be used, probably falls under this. And it's, I think, the most important part, because it's really just saying, before you worry about making the thing solid or repeating yourself, before you worry about making it good and actually great, um, make sure that you actually need the thing. Don't put stuff in there that you don't necessarily need, and then make it solid and dry. So I'm gonna let you just kind of jump in on it and maybe take over the solid part.
Yeah, like you can also replace Yagni with Kiss as well. That's keep it simple, stupid. Just the idea of don't overcomplicate things. The same principle. The example of this, again, a lot of this is great because I've seen this in practice, and you can kind of demonstrate where people do it wrong. Perfect example is a client came to us once, and they had a really simple request. It was kind of like the equivalent of photo filters. They wanted like fireworks on top of a photo in this little particle system. The programmer they hired decided to write his own particle system on the GPU with all these really cool GPU-based particle features, and it's super efficient and all this stuff. So he spent 2 months doing this, and they're like, "Yeah, can we have them like red, and can we have the glow around them, and they can do trails and stuff?" It's like, "Oh, I haven't done trails yet." And it's like, why are you like? What they want is some fireworks, and you're building a super hyper performant particle thing on the GPU. They ended up not working with that guy. They hired us. We spent 1 week, bought an asset on the asset store, tweaked it to what the client wanted. Bingo bango, they're happy, and they pay us, and we're done. Everyone walks away happy. Was his code fancier? Damn right. Was it more performant? Way more performant. Arguably, the code is better written, and he took better care of it than the asset we ended up using. But what did the client want? They wanted some fireworks, and we gave them some fireworks. And I think the fundamental thing is to understand the problem you're solving. And I've done this myself, where if you sit down and you're like, I'm going to make a weapon system or an interaction system or something, and you start going, oh god, but what if I have two hands and I want to grab an object and then I want to like let go and have someone else grab it? It's like, are you doing that? Well, no, that's not okay. Do a thing where the hand touches thing, you grab thing. That's it. Write that code. When that code is finished, stop and go, right, what happens now if I grab it with the second hand? Let's write that code. And you write code that directly solves a problem you have, and you grow the problem that way. And then as you go, you start applying the solid principles and go through all that. But the point is, the reason the rest of the stuff is even an issue is when you start adding features you don't need in the first place. So if everything's at least needed, none of the code is wasted. It just could be written better. If you don't start with Yagni, you're writing code you don't even know if you need. So you're adding mess on top of mess that doesn't even need to be there. It gets very confusing.
You often write code that you don't need, right? That ends up being redundant, overcomplicated, or just dealing with problems you don't have. Like, you want to be able to add that weapon to other characters. Maybe we're going to add other characters to the game one day. So let's make the system deal with that. Like, no, you're not going to add other characters to the game one day. Anything that's like a maybe we'll do this one day type thing, I would just assume is not going to happen. And don't build your systems assuming it on a maybe. Build your systems assuming things that you know you're going to do, the things that you actually have for problems to solve. And what about solid? You want to just briefly talk about what the solid principles are, or what it stands for? So if for people who don't know.
So the solid principles are effectively a bunch of rules that were consolidated by Bob Martin and a few others, but effectively they were already things people had said that he sort of kind of put together and then tidied up. And in fact, the original order wasn't solid. Someone else pointed that out to him and said, that's an acronym. Actually, you could make it.
Rearrange them, right? Because they were in the order that they make most sense in, but it was not a word. And like, hey, makes a word. Now it's a thing.
So yeah, it's just a series of rules to keep in your mind when you're writing code. Some of them are easier to understand than others. I guess we can just list them off and go through them.
Yeah, I just list them real briefly. Single responsibility principle.
Single responsibility. Yeah, single responsibility principle. Your things should do one thing. Now, I would say this one I actually have a lot of issues with because I think it's the most misunderstood, funnily enough. It's the simplest sounding one, but people often mistake that to mean every class must only do one thing. Now, technically, that's not what that really means. And if you do that, you end up getting yourself into this weird territory where you start writing these like 1-line, 2-line classes, which are spawners that can hot swap. It gets really messy. The way you should look at the solid principles, or we'll start with single responsibility. The way you should look at single responsibility is reasons to change and who wants to change it. So let's take a very simple example of a shop inventory thing. How many different things there could drastically change on you? The UI could change. You could draw it differently. It could be written by text. It could be controlled by an AI voice command bot. It could be a touchscreen app. It could be whatever else. That's one big chunk of stuff that could change. So drawing it is one responsibility. The second is what are you allowed to buy? Do you buy it based on what class you are? Do you buy it with diamonds and gems? Do you buy it with, various different trading systems? How that works doesn't actually matter how it's drawn, but that system can change. You might change the financial system of the thing. That's one responsibility. How does the rules apply? What are the rules to using this shop? And finally, when you're saving it and storing the data, does it matter if you save in a database or save in a text file or whatever else? And the question is, if you change saving from a text file to a database, do the rules of how the shop works change? No. Does the UI change? No. Each one of those three is a completely different responsibility. And the way to look at it is, imagine your team, imagine you are like every member of your team. You're wearing your artist hat and your programmer hat and your like database guy hat or whatever you want to do, and ask yourself each one of these people ask you for a change. So the single responsibility is each person that might request a change, not each line of code is doing one line of thing. So single responsibility is, does this do a thing? And sometimes a thing has multiple parts to the thing. So you don't have to split everything up into like micro pieces, as long as it conceptually means everything that changes about this changes together. That's how you divide that up.
Right. And I think your separation of just UI action or interaction and persistence alone kind of is a really good, I guess, indicator of where some of those separations are. You want to hit the open close principle real quick, the Owen solid?
Yes. Oh, this one is actually one that we've actually talked around this one all day. This is the one we've kind of been alluding to the whole time. Open close principle is so you want your code to be open for modification, or open for extension, but closed for modification. And what that really means is what we talked about earlier with prototyping. If you want to change how something works, you don't want to have to rewrite the code because you changed it. Because if you rewrite the code, you risk introducing regressions and causing issues. And like if there's an if statement with like 7 lines or 7 or 10 things in it, if you change one of the ifs, and if it's an else if or something, suddenly it breaks the chain, right? So that means changing the code, changing the features requires you to change the code. But if you instead use a system that allows you to swap things out, you can change the behavior without having to change the code. So an example for this I've used before is if you build a robot and a robot can shoot, they are a gun, then in order to change that shooting behavior, you have to open the code to change it, right? And so that's, you have to go in and like change how that behavior works. And so from an open closed perspective, that means that the file is open for change because it has to be in order to add the new behaviors. If you want to switch from a stun gun to a laser gun, you have to physically edit the code to do that. If a NPC has a weapon and that weapon can be given to it, the actual NPC is closed, as in you can't open to edit it, you don't need to, but it's open for extension because you can give it new extended behaviors without actually having to rewrite the code. So the open close principle basically means that you are closing conceptually the ability to edit the file, but still opening up the ability to change the behaviors.
I'm back.
Yeah. So before I jump to the next one, I thought I'd stop on that one because in case you had any thoughts on open close before we move on.
No, I don't. Other than I think that whatever you said while I was away from the keyboard was probably good. I don't know. If he lied while I was gone, please let me know in chat. He's just
Yeah,
sitting
I
there.
just.
It's like open close principle, useless, totally useless garbage. Stop listening to this stuff. I don't know. No, I missed it, but I'm sure it was good stuff.
So yeah, I trained it wrong as a joke thing, right? You know that. Yes, Liskov substitution. Oh boy, this one is very tough to explain.
Yeah, we can just let people read it if they want. if you don't want to go through them.
No, I don't know. I think it's worth going over because I do think the problem with if you give people academic descriptions, they'll tend to take the wrong meaning from a lot of them. So I find giving a little bit of a explain around is probably a good idea. Either way, Liskov substitution is one that it effectively means that anything that you use in a system should be functionally, if you build a system that you can swap parts out, every part should work the same way or be interchangeable from each other. It doesn't mean that they have to do the same thing, but it means that if you swap something out, you shouldn't get different behavior out of it. A good example of this is if you write some code which draws shapes and it draws the area of a shape. If you pass it a circle, area doesn't make sense for a circle anymore, right? Because you're supposed to be using the radius as opposed to you can't. There's either way. My point is if there's a feature of a system and one implementation of it requires you to like null a bunch of methods or have them do nothing or do something else, if the two things aren't actually comparable, they don't actually do, one of them is just like hacking into the other thing and like replacing some of its behavior, then you're kind of breaking the point of that contract. Your contract is wrong. If to implement it, I have to like mess with the way the function works, which falls neatly into the next one, interface segregation.
Can I jump in with another example on that list, Cobb
Oh yeah,
one?
sorry.
So
Yeah, go
like
ahead.
another simple gamey example would just be something like an animal that's got a walk method on it, right? Oh, animal that has a walk method that walks to a point, and then you override that with a bird class that no longer can use that walk method. Maybe it's using all the other things, the attack, the health, the name, and all the other stuff, but it's got this method on there that is in that base class that no longer works and is no longer applicable to the object that's the subclass. And that's what you want to avoid, right? Because then people call
Yeah,
that
like
walk
I think
method on it, and things you get unexpected behavior and unintended stuff.
yeah, that's a good example. Like actually, because it reminds me, I've seen examples like gun systems where a gun contract requires ammo and you have to like provide it ammo and reload it. But then you add laser weapons which charge up and down and don't use ammo. The fact that you're still using a contract that requires ammo to be defined, but you're not using it in any way, means that that implementation of that particular object isn't matching, so that it isn't Liskov substitutable, because you are saying these are two weapons. Oh, but just ignore the whole ammo bit when you're over here. It's like, no, you don't do that. That leads to a lot of confusion down the line.
You wanted to jump on to interface segregation?
Yes, interface segregation is basically, as we've discussed, stuff can do a lot of things, and so you end up with this scenario where it can be very tempting to make the god object, and you can have like the player, and the player does all of the player things. Players have health and weapons and animations and all of this stuff.
An inventory.
And so you end up with this like, it's doing too many things. And so what you'd be tempted to do is, okay, so a player is a character, and then characters all share actor behavior and whatever else. And so what you start doing is you say, right, what is an actor in my game? What is an object? An object is a thing that can move around. Cool. Then what's an actor? An actor is a thing that can move around, that can do behaviors. And then on top of that, I have an NPC, which is a thing that does this but has these other features. And so what you start doing is you start building a chain of, to qualify as a person, you need to provide some implementation of walking, eating, jumping, swimming, purchasing in shops, all this stuff. And you're like, okay, I just want to make like a wooden dummy that my player can attack. But to make any player or character or something, you have to implement this player object. And even though it's a wooden dummy that's never going to move or leave or do anything, you suddenly have to implement all of these behaviors because the base contracts you've built requires all of this stuff that's irrelevant. And so what you do is interface segregation says, okay, hang on a second. Is this really an actor who has all of this stuff? Or is there actually a person who buys things from the shop, a client, a shopper? Then there is a thing that takes damage, a damageable thing. And then maybe it just so happens a person can be a shopper and damageable. But hang on a second, a crate can also be damageable, but it's not going to buy anything from the shop. So the more you split up the interfaces, the more you can start to reason about, oh, I can just stack these together in unique chunks, and I get to reuse behaviors and concepts without sort of kitchen sinking by bringing everything from the old thing into the new thing, you know?
Yeah. It makes sense. And the last one, dependency inversion principle.
Dependency inversion. Now, the first thing to note about this is people often get this mixed up with dependency injection.
The dependency injection principle, where you inject everything with the BI container.
Yeah, so dependency injection and dependency inversion are not the same thing. The difference is dependency inversion is the philosophy or principle at play, and dependency injection is a way in which you can auto-resolve the principle which you're doing. So dependency inversion basically states that you can have low-level details, high-level details, and one of them can rely on the other. And you want your code such that it's inverted, so that it depends on which, how do I phrase this? You want to be able to change low-level details without having to worry about a ripple effect across the board. And that's what we were describing earlier. If you decide to change which database you're storing, even though every single thing in your game saves to the database, That's a low level detail. Like, we are storing in this exact database on these files, every single player, character, UI, setting, menu, all this stuff. That low level detail, technically, all of these things require that information. In order to know where to save, they have to know about it. And so you've got a dependency chain where somewhere up here, it needs to say the word database in order to kind of trickle its way down. But if you invert that, where it doesn't talk to a database, but it talks to a saver, a thing that saves things, and then that saver is up here, and it can be a database. Everything can talk to the saver, and now that dependency is inverted, because rather than being at the bottom, the thing at the bottom is saver, but the actual dependencies flow upwards. It's hard to describe until you've seen larger systems that do this, but effectively the idea is the difference between... Actually, here's a great one. I have a character and I want to log every time they shoot. I shoot a gun and I say pew pew and I shoot the gun. If I write debug.log inside that shoot method, that is a low level detail. And that means that when I call that function, it prints a log message. If I want to change that, I have to like dive down at the bottom of my code and change that method. If I have a logger, a thing that logs messages, and I hand that to the player, and the player says, log that you have shot, I can now decide to change that log message from going to the console to saving to a text file or going to a website. And that low-level detail of where do I send this message is something I can change without having to rewrite the code in the player. So I've inverted that dependency. I can now change that without changing this lower thing. So even though I'm changing a really low-level detail, I can do it without causing a ripple chain of effects. So you basically take behaviors out and you give them the things. Or to put it a very simple way, it's the difference between an is-at or has-at relationship. If you can give things behaviors, they can use the behaviors in different ways, and they can stack them to make new things. So the more you do this, the more you pull things out, the more you can make what's called a composition root, where I could say, this is a game world, it's using animals, the animals are all robots, and the robots have lasers. And then the game just runs. And then you can say, okay, what if I make it so they're not animals, they're actually monsters, and the monsters have ice swords and whatever. And these are like low-level details of how every piece interacts and talks and moves, but you can change it at a high level if you invert all the dependencies up the chain until you're configuring it up here and then passing them all down, right? So that's where the hard part is. It's not easy to do. It's very easy to do wrong, but it comes down to figuring out what a thing needs and then turning it into a contract and then passing the contract up. So you're muted.
Sorry, I was going to say, one of the things you think of it as essentially injecting the things into an object that it needs when you create or initialize that object, instead of having it needing to get those other things. It kind of, I guess, I don't know if it's kind of the way that I think about it, I guess. It's just injecting in dependencies for things down the chain, right? So that things inject or pass in the dependencies that objects below them need, and they give them to that object instead of that object needing to.
An example I've used before: if I made a bomb class and I throw bombs, I could write something called a ice bomb or a fire bomb or a poison bomb, and inside that code is a thing that says, oh, when the bomb explodes, it does ice damage or something. And then I would instantiate those items in my classes, and then that's now low-level details and set up. But if I instead had something called a bomb creator, and a bomb creator has a function that says create bomb, and it gives me a bomb back, I could now, in the bomb creator, say this bomb creator creates bombs of type whatever type of bomb I want to use. I can now give the bomb creator to my weapon, and now the weapon doesn't even know what kind of bomb it's making. It's making some kind of bomb, and I can make that decision later up the chain rather than in the code itself.
Right. One of the things I think is different too with Unity and just regular programming with this is that some of this dependency inversion is coming from your prefabs and your scene setup and your game objects. All of that allows you to do some of this inversion as well. And you'll see that some of it kind of like merges in there. Some of the things that you've talked about, the ways that you set up systems, you might do those in code, or you might just do them by swapping out your prefabs because you've built your system in a way that your dependencies are those prefabs, and you're just injecting them in your scene or in another prefab or something.
100%. If you pass an object in as a serialized reference to another object, such that you can mess with that object and affect it in multiple places, you're also inverting that dependency.
Yeah.
You're actually falling into what's called a strategy pattern and doing stuff in that direction. But that's perfectly fine. Unity sort of took away the main way that you do dependency inversion via constructors because they need that themselves based on how they're using activations and stuff. But in contrast, they gave you back serialized objects in the inspector. So they gave you a different way to do it, but it does the same thing.
Yeah. Yeah, it's essentially a different way to do it. So I want to hit the next one now, the pencil and paper. So I just popped it up real quick, but I'm just bring it up here. And it said that pencil and paper are the best programming tools and vastly underused. And on this, I agree. I've got notebooks. I mean, I have 2 notebooks on my desk now, 3 right now, just from random different stuff that I'm writing down constantly. And it doesn't necessarily have to be pencil and paper, but it's generally just non-code ways of putting stuff down. It could be a whiteboard, it could be some online board that you use or something else where you're not writing code and you're really just either thinking out, like planning, getting an idea of what the problems are and how to solve them, or the reason that pencil and paper are probably the best is because you're also drawing them out, diagramming them. You can draw an arrow between the things that are related, the loops, and you can circle the stuff, and you can just, I feel like, get a much better idea of how the project works and how things need to tie together than when you see a bunch of class files, right? You see a bunch of code and you write a bunch of code. It's a lot harder to kind of get the idea of how stuff works. What I like to do personally is look through my code with a piece of paper, write out the classes, see how they're tied together, and I'll draw lines physically and I'll look for the problems because it's a really easy way to spot issues in my code that I want to fix. So yeah, what do you think? Do you use a lot of pencil and paper?
100%. I
I think you do.
use so much pen and paper. So my advice for pen and paper is I agree everything you said in terms of how you use it, but I think the main strength to pen and paper as a tool is actually something different. It's the fact that you have to think away from code. So one of the biggest mistakes I see junior developers make is once they understand enough code, they start to like think in code. What I mean by that is if you know you have to use transforms to move things, and you know you have to use raycasts to point at stuff, when you try to solve a conceptual problem, in other words, what feature does my cool new laser gun have? You'll be mentally thinking, well, then I'll do a raycast and I'll move the thing and I'll put a vector there for the transform. And suddenly you're like, hang on a second, just write down gun shoots. Gun does a shooty thing. Shoot stuff. And then from there, you go, what does it shoot? Oh, well, it's going to shoot lasers. And so I'll have a laser thing and I'll have settings for lasers for like how strong it is and how it does. You can clear your head and not think in terms of the mechanics of how it works by trying to solve it as what do I want first? And then you can go in, write the code that conceptually gets you what you want, and then kind of inject in or just like build later on top of that the skeleton of what you've made, the details for how that works. So if you try to think through code, what you'll do is you'll start meandering and writing stuff, and you'll start writing functions you don't need and deleting stuff and going back up a chain and trying different stuff, and you'll find yourself spending a lot more time than if you first just get your thoughts clear. I've said this before. The whole point of writing code is to kind of codify your intent. I want X, and I write the code to tell the system how to do X. If you don't know what you want yet, how can you write the code? You can't write the code if you don't know what you're trying to do. And so if you try to figure it out with code, you're going to make your life harder. So figure it out first. I want a thing where I have teleporters, and when I stand on the teleporter, a cool little animation will play, and I'll zip over here, and then this will explode, and this will happen. Once you understand that, you can understand what systems you need, and then you can start writing the code. If you start thinking code first, you'll limit your entire design down to, but I don't know how to do that, and maybe I'll need this thing, and where would I get the particles for that? So reason it out in like the freedom of pretend you could do anything in the design phase, and then cut it down sharply by the time you get to reality, but don't design through the code.
I think that makes a lot of sense. The abstraction and the getting away from the actual implementation, I think that's a really good point. It's an important part. And I think that if you pre-plan your implementation and you get that too much in paper too, it can be a big problem. Like I've done that where I've pre-coded stuff on paper and like figured out my methods. I figured out my classes and my methods and everything on paper. Never lines up. Never once has it lined up. I need to figure out the bigger architectural abstract ideas, and then I convert those into code. It works way, way better. The next thing on here was that trading purity in exchange for practicality is usually a good call. So keeping things, this has been something that I think I struggled with when I first started getting into design patterns, and I started finding like, okay, this is the way that it's done, this is the pattern, and trying to like stick really hard to a specific way or a specific pattern and not change anything, and then ending up essentially over architecting and over engineering and making things more complicated than they needed to be in a lot of cases. Have you run into this problem too, where have you seen this? I assume you've hit this, but I don't know.
It's one of my big ones too. This was one I spent years fighting with. In a particular example of this was, again, architecture is my thing. If there's one area of code that I effectively get paid for, it's to consult on architecture. And because of that, when I first started learning it, I got really dogmatic into these are the patterns. These patterns have been written by people smarter than me, shoulders of giants and all that, and I will follow them to the letter. And it actually took a very long time for me to realize that they represent solutions to problems. And if I don't have that problem, I don't need that solution. And I have to start thinking in terms of applying the right tools that I need. And it really, like, I was even still struggling with that idea until only a few years ago, when it was actually Jonathan Blow doing not one of his talks. His talks are great. I've watched those, but it's one of his random, like 2 hour long programming streams where he's just in the middle of solving some programming problem. And he said something that really stuck with me. It's very, very funny. Is so he's well known for a guy who is all about performance in code. He thinks everything's gotten really clunky and messy and too large, and he kind of hates the layers of stacks of abstraction and stuff. So from a purely philosophical standpoint, he's almost exactly the opposite from me. Is that if he can get away with writing stuff as flat as possible, he would. He doesn't like architecture. He sees it as a necessity of, you need to do it when you have to, but he doesn't actually like it as a thing. And so I like his opinion because it's, again, so contrasting to mine that it's valuable to see why that's the case. And so when I was watching him solve a problem, he had an issue with lily pads, and he had a character that the game ran on time steps, and lily pads would move along and the player would try to walk on them. And so the animation, though, was running at a different rate than the actual background tick. So think of it like a grid of cells, and things are moving into cells, and some animation moves it along. So there's conceptually a moment where you could or could not step on the lily pad that isn't there yet because it hasn't animated into the right position. And he was looking at this, and it didn't cause an issue 90% of the time. But there was this one edge case in this one corner where it was happening, and it led to a bad user experience. And he just wrote a very specific piece of code that solved that specific problem. And I was like, clutching my pearls going, you've got this really cool system that works for like 50 levels. You can't just write one if statement that fixes it in this one weird edge case. That breaks this really modular, nice, neat system you've got. It breaks. And he's like, why am I doing this? What is the point of all of this? Well, it's a user experience. I want players to have a good time. If they do this, they'll have a bad time. If I write this code, they'll have a better time. And so what's more important? That the code that nobody sees is cleaner and fancier and more modular, or the experience is better. And I was like, damn it, he's 100% right. I can't argue with the idea that the point of the code is to facilitate the requirements, and the requirements should always supersede that. And so combining that with the idea of business, if someone asks you to build a system, this is one thing you're going to fight a lot with as a programmer. You'll get clients ask you for something, and your response in your head will be, but the system can't do that. The system we have doesn't let the thing you want happen. And you might cross your arms and go, well, it can't do that. We can't support that in our system. So tough. It's like, well, no, the problem is they want that. Your job is to figure out how to make that happen. And if you have to break some of those purity rules to do it, then that's the point. Then you can reevaluate the design and possibly refactor things later. But the truth is, getting the actual issue solved is the most important thing over everything else.
Without a doubt. And the best way to do that is to add new technology, right? If you can't solve the problem, you just got to bring in more tech. So the next one on there was that adding more technology is rarely a good call. 3000% agree. I so many times people see like a new bit of tech, a new thing that came out, and they're like, oh, that's really cool. Has nothing to do with our game. Or it's a tiny little thing, and end up just investing and investing and investing time and energy into diving into some new tech that ends up either not adding anything or adding very little for the cost. And I mean, to be honest, it's not like this is another one of those that I've done myself, right? Like I've brought in new tech and new stacks and things to stuff that just didn't need it. Where I was like, this is really cool. This is really neat. If we scale to this crazy number, this is going to make it awesome. So, and then you end up not scaling to it. It overcomplicates things. People get confused, and eventually the new tech either gets ripped out or becomes old tech, and nobody cares, right? So it's yeah, adding new tech is usually not a good solution to a problem. Like adding something new that came out. Have you run into this problem yourself?
I've both done it myself because every programmer loves the new shiny toys. I
Yeah.
remember working on a project in some company where we're building a website and we were using Angular. And I'm like, but everyone's talking about React now. All of the cool people online are saying React is better. I want to make it React. And it's like, well, we have a website. It works. We need new features. And they're like, why do you want to remake it? And I keep like, I'm like lying to myself, coming up with, but it's faster and it has better support on these. Trying to convince them that it's a good idea to let me on their dime learn some new technology because it's fun.
Yeah.
Yeah, it's silly. Like it's exclusively just I want to play with the new toys, and I ended up not doing that. I fought my own instincts on that eventually. But the other side of it too is the vendor lock-in problem. You often get a business person who gets wowed by some vendor who's like, "Oh, have you seen the new toy? We can hook into all of your systems and debug all of the stuff and give you a dashboard and whatever. Your developers will love it. Here, force them to use this in their projects." And so you end up getting new technologies added to your stack of complicated things. And yeah, every variant of that I've used at some stage. I've had some, or another one. It's another very very common one is when when people see a new tech and they just want to find a way to use it. I've been in meetings so many times with people where they're like, okay, so everyone's talking about blockchain at the moment. So how do we put blockchain in our app? It's like, well, what problem do you want it to solve? It's like, well, I mean, we want to be able to
You
use
don't
it.
have blockchain in your game yet. That's the
Yeah.
problem, right?
It's like,
You've got
just
no
yeah.
blockchain tech in your game. What kind of game is it? Now, I've
Yeah.
literally had that conversation with multiple people who want to put blockchain tech in their game. No idea why, just because blockchain tech is popular. And I mean, I've done things like that myself too. So I can't like badmouth anybody for it 'cause I've done it too. But yeah, it's a big issue. Adding new tech, just really heavily consider whether or not it's going to make you solve the problems that you have and solve them in the right way.
But I would say inversely, it also can be true. So be very careful as well about not being entrenched in tools. So you can find yourself in a position where you know one language really well or one tool really well, and a new problem comes along, and the tool you're using just doesn't work for that thing. And so you keep like I remember spending a long time trying to convince a company I worked with to use C Sharp and ASP.NET for their website. Why? Because I like C Sharp and I'm good at it. It's like, but the truth is, the features they wanted would have been served so much better with a mean stack website. And I eventually bit the bullet and I accepted that that's probably the right approach. And I just went and learned a whole bunch of new technologies that I didn't know because that's what they needed. And I was using the wrong tools for the wrong job. So it can work in both sides. It comes down to pragmatism. And it kind of feels like we're banging the same drum, but like learn the problem, solve the problem, apply the right tools to the problem. And all of these different shiny new toys are not going to help one way or another.
That said, I do want to mention that people should still like keep up to date with technology though, and keep like don't keep using old versions of stuff. Don't only use old technology. Don't use Unity 3.5 or whatever you're doing. Like keep up to date with the new stuff, and definitely add new tech. Just don't use it as a like it's going to be a magic solution or it's going to suddenly make everything better, because most of the time it ends up just adding a lot of work for a little payoff. I want
And like
to
I just
go
have
ahead.
one last thing to that too. And also like if you're kind of college-ish or pre-college age, you can feel free to be on the bleeding edge, right? You can play with the new toys, which
You
are
should.
brand new and coming out, and they're kind of fun. Like right now, if you have time, go learn some Blazor. Blazor is cool. It's a fun new
Mhm.
wacky way to kind of combine web stack stuff with C sharp. But if you work in a company, don't do that to your poor company that you work with. Don't try to like shoehorn in alpha projects that are bleeding edge because you're learning stuff which mightn't even survive. Like I remember in college I was learning Silverlight.
They were like really enforced. Silverlight's the new thing. It's Microsoft's version of Flash. It's going to replace everything. And then
Almost
years later,
used it at Sony on some projects. It's like, oh,
Yeah.
maybe we'll use this for some internal stuff. Yep.
then it dies. Then it's just gone. Like whatever. So don't lean too heavily in. Now I'm at the stage where I won't pick up a new tech until it's gotten to the point that it's proven and robust. I'll still learn it, but I'll wait until I see it's got legs. Like I've been watching Timeline and the new input system in Unity for a very long time, literally years. If you look back, they've been talking about this stuff for a long time. There's been alpha builds. You could try them out. I've tried them out once or twice. I never did a project with them until very recently. And in the last year, I've done quite a few Timeline projects because now it's good. It's really good. It's one of the most robust systems in Unity at the moment. But until it's needed, don't play with new toys. If you're in an enterprise scenario, if you are younger and you can afford to, that's the perfect time to learn all the new tech and to kind of get a better sense of what the landscape's for.
Yeah, or if you're just experimenting on your own, that stuff's fine. Just don't try to bring it in on your real projects. So the next thing on here, there's a bunch of them, and I want to get through them kind of quick before we get our last 15 minutes. Was that talking directly to customers always reveals more about the problem in less time with higher accuracy. And I'd say that's in comparison to talking to the management or the QA or CS or whoever the customer has talked to. If you can actually go there, sit there, watch them have the problem, see the problem, you can solve it almost instantly most of the time. If it has
And
to
just
go through the translation and then multiple translations into a bug report, way more complicated and way slower. You're like 10xing the time to do it.
And if there's one bit of advice to anybody who ever finds himself working for a client, there's one thing, just one bit of advice to keep in mind. Clients will ask for something, and this may sound a bit rude, ignore what they ask for and ask them what the problem is they're solving.
Oh.
Because oftentimes people will diagnose a problem themselves and tell you they want this solution. It's like, oh, I broke my leg. You're a doctor. Can I have a plaster or a Band-Aid? It's like, hang on a second. What is your problem? And can I try to fix your problem? Because I know my tools better than you do. So ask them what they're trying to solve and offer solutions to solve their problem. Because you'll find you'll waste so much of your time. You'll hear a problem. You'll work on the solution that exactly what they asked for. They'll get it back and go, oh, but that doesn't do what I want. It's like, well, that's what you asked for exactly. It's like, yeah, but that's not what I want. And so you will save yours and their time by understanding their problem. And just like Jason was saying, I'll go and sit with them. I'll go and ask, hey, can I just like sit beside you while you work for a few minutes? I just want to know what you're doing and what can I do to make that easier.
That is always the most valuable because they're trying to help. Right? When they give you the solution, they're trying to be helpful. They're like, "Hey, I want to make this as easy as possible. This is the problem. I think this is what they need to do to fix it. I'll just tell them the solution, so that way they don't have to come up with it." But yeah, most of the time they just don't know the stack. They don't know the underlying things enough to know what the right solution is. So let's see. The next one was about engineering, and it says, despite being called engineers, most decisions are pure cargo cult with no backing analysis, data, or numbers. 3,000%. I don't know. And when I do see data and numbers, they're always made up data and numbers from like, hey, let's put these in a sheet. We'll give it a value of 1 to 5 or 1 to 10, and then everybody will just pick numbers. So that's the kind of numbers that you usually get when it comes to most decision making. Every now and then you'll find somebody who's got some actual analytical data to back something up, but this says most, and I would say that's probably 98, 99% of decisions are just no analysis, no real data or anything behind it. It's just, what do you guys think? Who has the strongest opinion and the strongest personality? Right?
The clearest one for this is if you're starting a new project, you've got a room full of 10 developers, and you're trying to figure out what language you're going to do it in. I'll tell you this every time. 90%, it's going to be the language that the senior developer likes the most. That's what you're going to do. That's what you're going to use. It doesn't matter if it's the right tool for the job. It's going to be whoever is the most senior person is going to pick the thing they would like the most to use, and everyone else is going to just go with them because they sound like they know what they're talking about, and they're the one probably going to be solving the most problems.
Yeah, that's pretty much the case. So this next one said that, and I think it's kind of funny, 90, maybe 93% of project managers could probably disappear tomorrow to either no effect or a net gain in efficiency. Maybe. I would say this is probably a bit of an exaggeration on what would happen if they disappeared, because project managers, in a lot of cases, at least a chunk of what they're doing is pretty valuable. It's just that they tend to cause a lot of inefficiencies and do things because most people that are project managers aren't project managers because they're good at it. They're project managers because they can't do anything else. Right? Like
So
they
here,
like talking to people, but they don't know how to do any of the other jobs at the company. Is not that they can't do anything else, but they don't know how to do any of the other jobs at the company, and they might not even know how to do project management. Right?
in fact, actually, the biggest example of that is something called the Peter Principle.
Yes.
And the Peter Principle states that any developer, well, actually any employee in general, will end up being promoted until their absolute maximum level of incompetence. Because what happens is, if you're good at this job, you'll do so well, you'll move out of it to the next job. And if you do so well at that, you'll move out. And the inevitable track is, oh, they're a great programmer. They should lead other programmers. Okay, cool. Are they good with people? Are they good management skills? No, but they're a great programmer. Okay, so they should be in charge of not writing code and now managing people. Wow, they're now working as a senior manager. Well, they're doing okay. They should manage like projects. That's cool. Have they ever done that? No, but they've been doing the people management, so they're probably in, and it just keeps happening until people are bad at their jobs. That tends to happen a lot. Though I will say
that happens all the time.
Yeah. And again, it's people look at it too. Just because your boss is incompetent doesn't mean that they're not doing it to spite you. They just might have preferred being a programmer. They just got stuck in a role they didn't want to do, right? That happens a lot.
I've known a lot of lead and programmers who were put in charge of management stuff that didn't really want to be. They took it because somebody had to do it, and there was just like that was the option. Like they kind of had to do it or find another place to work, essentially. And they thought it would be the best for the company, but they don't like doing it. They would really prefer to just be a senior programmer that has a lot of input and insight onto stuff and a lot of control, but not be the one managing and dealing with all that stuff, because it's a totally different job. So yeah,
but I will say that I'll pull a rank on the article for one thing. The article is titled "Things I've Changed My Mind in After 6 years." Well, I've been doing this longer than 12 years, so I would say in this one case, a lot of developers dislike project managers because they see them as somebody holding the reins, not doing any work, and not understanding the job. I'm not saying there's not bad project managers, but as someone who has climbed those ranks, I have done grunt programming up to the point where I'm managing teams. I have a lot more respect for what that job is. And just because that person's job isn't literally sitting there typing code and you don't see what they're doing, you have no idea how much of a project manager's job is people management and making sure expectations are on track, and how exhausting it is trying to plan and structure a project at that scale. So I would say project managers, oftentimes they may lose touch with the dev stuff, and that might make you think they're not good devs, but that's because they have a whole other sea of the company to understand. They have to know budgets. Their decision making is driven on how much money is going in and out of the company, who's there, what people are promising things, what big contracts they're going to get or lose based on whether they have this feature in on this date. And just because they come to you and say, hey, can I have this thing in 2 weeks, and you roll your eyes, doesn't mean that what they're not telling you is that'll be worth 2 million to us if you do it, right? Like they have a lot on their plate sometimes that you don't know about. And so I would say just give them a bit more slack than a lot of devs actually do. Is they may be angry or stressed or frustrated or bad, but sometimes there's a reason. Just trust me on that.
That's definitely a fair point. And I think that the better project managers communicate some of those things well. Like they communicate that, hey, this actually has a lot of business value, or this is a nice to have thing, but it's a low business value thing. So do you have other higher priority things that we should focus on? Because a lot of times the animosity towards project managers comes from changing priorities into something that's not a high priority. And then like you waste, 2-3 weeks working on something, and they're like, oh yeah, we didn't actually need that, we're canceling that, go back to this other thing. And you're like, oh. And
Which
those are the kind
I've
of
been both
project
sides of
managers
that.
that build up
It's
that
so
animosity.
annoying. Yeah, it's so frustrating when someone says, hey, you know that thing we asked you for, you spent the last 3 weeks doing? We don't need it anymore. And that used to really drive me insane. But now I look at it as, oh, you don't need it? Cool, which means your requirements are being met. If you shift your perspective down to people don't respect my art, the work I'm creating, and look at it as their work, and are you achieving their goals? If you don't have to do it or it's not being used, their goals are met. That's a win for you. Take those wins.
Yeah, I agree. Let's hit this interview one, and then maybe we'll hit the opinions afterwards. So this one said, after performing over 100 interviews, interviewing is thoroughly broken. I also have no idea how to actually make it better.
And same in even the same amount. Like I also don't know. I hate interviews. I interview really well personally, but not technically. I'm a bad technical interviewer, but I'm very good at the social portion of it. and I hate both. And the last people I hired, my expectations vastly different, and things went completely opposite to what I expected both times. So I don't know how to. I thought I knew how to do that. Even if I'm good at people, interviews suck. They're just, you cannot gauge anything from an interview. I've give up. I just don't know anymore.
It is very, very difficult. I think that the best ones that I've seen and the best stuff that I've seen with interviewing includes actually doing some sample work, like some example projects. Although most of the time nowadays with those seem to be paid projects. So, I mean, back when I used to apply for game jobs, I would be more than happy to go, spend 8 hours building up a sample project to show that I can do this thing for this game. I'd love to work here, and this is it. Like, hey, not a problem. Like, I literally would get excited to do those projects. They'd be like, this is my chance to show off. A lot of people fucking hate them. They like throw a fit. They're like, this is stupid. They made me do this thing and I didn't even get a job, or they want me to go spend 4 hours building a project to apply. And I can understand the frustration, especially if it never
I
pans
won't do
out.
those anymore. Yeah,
Yeah,
if a
if it
company
never
wants me to
pans
do
out.
that. Yeah.
Yeah, I wouldn't anymore now, but I mean, back when I was starting out, I would gladly do it, and I had fun doing them too. Like, I actually enjoyed doing the projects and submitting them and seeing if I could get them in and how they would come out, and then being able to talk about them and show them off. I thought that was a lot of fun. But overall, most interviews I've been to and seen, they're just terrible. I mean, it's because you have programmers interviewing people, and programmers are not good interviewers. It's just like we were talking about. You've kind of pushed people up to this job where they have to do something they're not good at, they don't like to do, and nobody outside of the job can do it well either, because they can't judge the skills, right? You can't judge somebody's programming skills if you don't have any. So it's a very difficult thing, and I also don't have a great idea on how to make it better, other than doing the sample projects and having those be paid ones. Seems to work pretty well. I know a good friend of mine's done that a couple times recently, where he hired new developers and he had them basically build out a sample project for a couple $100. It was an actual, like, a thing of their product though. It's like, hey, this is a part of our product. I want you to build out a replica of this. And here you got 8 hours. We'll pay you whatever, $50 an hour or whatever the rate is on it. And if you turn it in within 72 hours, we'll move forward. That kind of thing. So I think that can work. But again, it's difficult to get people to necessarily do that. But I don't know. Maybe it works out well. Anyway, there were a couple more things on opinions that changed, but I know you got a premiere about to kick off in 3 minutes, right?
I do.
So
And
I want to just get everybody sent over to there.
Okay, cool. I was gonna say I'm gonna be in the chat there. So any questions that people have? So.
Okay, cool. Yeah. So if you're not already subscribed to Jason Story's channel, check for the link down below. It's right next to the game architecture course link. You can check that out too. Go click over it. You should be able to go straight to his premiere that we're both going to jump over to. I'm going to watch it and join in on the chat too. And Jason will probably be there chatting up a storm and answering questions and hopefully getting. Have you broken the 1,000 subscribers yet?
That's a good question. Have I? Let's find out.
They're just about to break it. One of you guys might be the 1,000th.
Yeah, if you'd like, you can try now. It says 997 here, so there's still a few slots left.
Somebody's going to be the lucky number 1,000. So just look down in the description, find the link to Jason Stories. God, the pointing is always backwards. One of these days I'll get it right. Find the link to Jason Stories, his thing. Oh, Sarvin was number 1,000.
There we go. Nice.
All right. Well, congratulations. And thanks again, everybody, for joining us. I hope you guys had fun. This was an interesting discussion for me. If you liked the way that we did this, kind of going over this, I guess, kind of pre-written thing, which I think was kind of interesting. Let me know. Let us know in the chat or in the comments down below, and hit the thumbs up button and share the stuff. It helps a lot. And I guess everybody come jump on over and join Jason's stream in the next 1 minute, and I'll see you all there. All right. Thanks again, everybody. And goodbye. Somebody mentioned flipping your face in the camera. The problem with that is all my text shows up backwards. The relax is backwards. The word, yeah, I've tried that. My wife asks me every time, like, everything's backwards, so you can't read it. All right. Thanks again, everybody. We'll see you soon, or in just a second on Jason's stream. All right. Bye.